Is Astronaut sure?
No, not yet.
Okay, cool.
Microphone's on.
That's fine. Okay. Can I have members of Build around?
What?
Can I have members of Build around? Around that. What's going on? Programming. I need to get away from programming. I'm going to be focused until Cal's sick. Can I get an idea of what was done yesterday and what your goals are for today?
We have a 6-sim drivetrain, or not 6-sim, you know what I mean, 6-motor drivetrain program. That's what we have. At some point we want to go on stream and show how to program a blank number of motors drivetrain on the stream.
One question I do have is my priorities again in terms of design, programming. We're going to have a design meeting. So for programming, what I would really like to see is that, in fact, some of the mechanisms, mocked out some of those mechanisms.
Yeah.
I don't know.
That's what we're planning on doing.
So in terms of like the spinning wheel, like having some of that, the math done for the spinning wheel in terms of how we're going to stop in a specific color, how we're going to spin it a certain number of revolutions. There's still a lot of math to do there, regardless of whether you have the right parameters for the shape of whatever our mechanisms are. So those functions need to be done like 12-ish for three specific components: our intake, for our climber, and for our intake, our climber, and our spinning mechanism. So since those are what we're focusing on, and starting from the intake. And so intake is just spinning a wheel. And
yeah, I don't see any math anywhere there.
And there should be no columns there from what I understand.
I don't see any math any of these mechanisms.
As far as I understand it, we're going to have to run the spinning mechanism for a specific number of revolutions based on based on input from.
Okay, that's a little bit of math. That depends on the encoder. That's easy stuff. That's easy. You're telling me easy things to do that I'm planning on doing.
Okay.
Anyway, so they will happen.
Understood. I need to understand the converting from how.
Okay. Sure. They're probably going to happen like now.
Okay, cool. That's totally fine.
a hold up there, and we'll just give it back.
Understood.
So,
Okay. Cool.
and
What is your? I'll be working on less vision for today. What else from you in terms of your personnel? Do you have an idea? The other thing we're going to talk about this in 9:30, but what else do you have like an idea of how many people you're going to have today, and what's going to be able to be gotten done? It's not just you, so that's why it's
Thomas is coming back. Kaiser's coming back with a second camera. Target will only let you price match one item at a time, including against Target's website. So yeah, those are like $30 marked down to $22 for today, but they need to be $17.99 because that's how much they are.
Right.
So anyway, so he went to a different Target and is picking up a second one. Yeah.
Cool.
And then so I think the plan. I think I'm gonna have Thomas and I do the video on stream,
Okay.
and then
Thomas is not going to be here till tonight.
oh right, I forgot to say there's 7 or 8 tonight.
Yeah.
Forgot about that. Okay, so then it'll be someone else and me.
Okay.
And then we'll probably just divide the mechanisms.
Sounds good.
I mean, there's only going to be 4 of us at most.
There's only going to be 3 mechanisms, so
Yeah.
one per mechanism sounds good.
Yeah.
Okay, cool.
We'll get
going.
Yeah, he wants all three things by noon.
He managed his space while running a leadership meeting.
I have a question.
Are we on getting some?
Yes.
Something in the stream app.
Like,
Yes, what is your job?
Not as here. Not as here.
okay.
No worries. Just chill. Make sure people don't hurt themselves.
Is the Twitch chat thing pulled up over there? Is the Twitch chat thing pulled up over here?
Yes.
Yeah, I know, it's not ideal.
Like I might miss a period in my Did you go home last night? Yes. Okay. I was about to say, I went home last night because I wanted to steal this from my shop.
Yeah,
So
that
we
makes
could
sense.
program without needing that. Yeah. And then I have you guys at PC over there. Yeah. So, yeah. So. Done.
The kid feels like we want three mechanisms like ready for deciding which ones we're gonna be using by noon.
Oh, yeah. And he wants programmers to program all.
Okay, I'm not saying about the programming is a lot different.
I was going to say programming it's a lot easier. You can just copy and paste code.
Especially when these are just simpler mechanisms, and then he's like,
everything's motor on, motor off.
he wants.
I was about to say, yeah, it's motor on, motor
He
off,
wants.
but it's all the
Okay,
same.
I want
It's on
three
canvas.
different mechanisms. He wants. He wants us having. He wants us having a lift, an intake, and something for like the control.
Yeah. He wants the spinning wheel, an elevator for climbing, and
Yeah, he wants that by
intake.
noon, and then
Yeah, he wants that done by noon, and then by 3 o'clock we need to decide whether those are the prototypes that we're using or not, so that we can start building the real things.
you want a strategy meeting.
Like, that does
And we
not
don't
sound
even-
very cash
Also,
money.
we can't even test like any of the ideas that we have like until 11, because the guy's leaving for home. He's leaving at like 6 or 5. The power cell.
Yeah,
It's only like,
yeah, no.
Okay, I
Sort
know.
of slight dimensions. All it takes should be enough.
Well, you know what I mean. How it
yeah, I was about to say, it has to be 7 inches. It's
You
a
know-
slightly compliant ball.
Yeah.
Just make the
It
intake.
just takes Stronghold here and then just modify it because it's the same ball.
It's the same ball with 7 inches instead of like 10 or something.
Yeah.
So it has compliancy. So like when I was with my team yesterday during the morning, because I wasn't here, we figured using like something that's like 6.5 inches, 6.5 inches from like wheel to wheel or whatever's actually picking it up should be enough.
It's more just.
And then I also told my team that the idea they came up with is illegal. They wanted to use an elevator to go from the upper goal, and I'm just like, you can't do that. That violates G17.
so high.
That's the one cow, bro.
I'm pretty sure.
No, this is.
That's not
Also, keep in mind, this one is on right.
Yes, the actual robot on that. This is just.
Are we in the way?
Regardless,
Are we in the way?
that's the street view though.
I made this board last year for my because I told him I wanted to do a pop-in electrical board in out of any robot one. It's awesome. So I can put this in the Twin Stronghold bot, the Steamworks bot, the Power Up bot, Destination Deep Space, and it's probably not going to be able to fit it in a rolling machine.
That won't mean anything personally to you.
Not right now, what?
But I'm just figuring if I need to start.
Oh yeah.
Like, I'm trying to do, I could, I'm, also, I'm just gonna say,
Can you
if,
3D print an elevator?
yes, but not at full scale.
I mean, yes, just piece by piece.
I was going to say, yeah, piece by piece and like each.
You can put the bearings. You need everything short of bearings, like the rollers.
You
and
can make
everything
the
else.
I was going to say, well, I mean, the bearings and stuff, you could probably print those like stuff to print halfway through dropping your own.
No, you can have it, if you're
Yeah, you
using,
still have to do those.
if you're using a different printer, you can have dissolvable, supports and the supports will dissolve in the bearing.
Yeah, but that's not what he was talking about. You have to stop it.
Well, no. I was stopping it midway print and adding stuff that you can't actually print and finishing the print, so then it's in there.
Yeah.
So you can print like legit bearings.
Yeah, for ball bearings, you print the ball. You just drop the balls in all the way around.
So their strategy meeting is probably going to take a little bit, anyways.
Their meaning of like what direction, they're all good, probably the two mechanical school and everything, like you're being unreasonable.
No, three prototypes of each is reasonable in that.
No, but I mean like choosing.
Reasonable in 2 hours? Okay, give us 3.
I was about to say, like, getting like 2 or 3 different prototypes for each thing by like 3 o'clock would be reasonable.
Yeah.
And then deciding on them by like 6. That's very reasonable.
Yeah.
But like, having 3 fully done prototypes at noon to be able to vote on.
Oh,
Of
that's
three
the
different
first time
times, of 3 different times, it's not even the same
Yeah,
time.
so 9 different prototypes by
But he wants just 3. But the thing,
What's 3 and 6? 3 on
wait, 3 of each?
That's what you guys were saying.
No, I said he wants 3.
one. Yeah, he wants one of each of the 3 different things. That can all integrate on that West Coast strategy.
Oh, that's easy.
Yeah. A elevator, A
Yeah.
intakes or slash shooter, and
That
then
should be lunchtime. I'm gonna grab my computer. Oh, nobody else uses the CAD. I only have SolidWorks. I only have SolidWorks. Someone's gonna have to convert.
You can convert.
you can convert using SolidWorks to an STL, and then most slicers take STL HG code. Major files.
Good mind. Yeah. I'm originally the same.
I was about to say, yeah. Noah Haskell told me I was probably going to either need him or USB.
I'm originally the same.
Huh? That's the free antivirus I got when I got this.
USB stick?
Yeah. I was about to say, no, I'm pulling it up on my computer. And once it said it was going to take like 2 days to download, I was like,
have the inflection video.
I think I have the inflection video on Flash drive.
I did also just like blow like faster.
You have an SSD?
Yeah.
I think I have it.
Oh yeah, see, this is already further than I got. For over business use, that's already further than I got.
Go ahead and try to install it on there. And are you meant to it's easy Wi-Fi
Yep.
or
It's easy.
computer Wi-Fi? The device needs to reinstall, restart.
Yes.
In the Slack, you know, on Slack on the computer.
I don't have Slack.
I'm gonna give you, once you uninstall that, I'm gonna copy your string of characters to the Slack drive. I'm gonna paste that in, make a folder in your desktop or wherever, call it RFID, or whatever you want to call it. And sync will put all of everything in the same folder.
Choose a page.
Yep.
Okay, David Brooks. It's saying as it did not.
It's
There's also like the things of like the low health ratings. Like the Western, like McDonald's on Western, I pulled it in. They had like an 84 health rating. I was like, yeah, no.
On Cameron Village Drive, if you go through
Yeah, that's up by my care.
Cameron Village, you go out here, just go straight out, across that new road, that goes by the church, behind the church, and you go up Pullen Drive. And you go up Pullen Drive, you keep driving through Pullen Drive across Oakland Street. That's it.
Yes.
Right?
Yes.
That's where the Harris Theater is. There's a Chick-fil-A. There's a chicken and waffle place up there.
There's Smash Waffle on Wilbur Street.
There is that. There's like a chicken place up there. Chick-fil-A's. You can also drove by McDonald's. You drove by Hardee's.
It was
really good business.
it was like to be fair, it was like 7 this whole
Yeah, like Hardee's is open at like 5.
Yeah, but I also like don't like eating when I first wake up. Because I have medicine that makes me feel lazy in the morning.
I think you're almost halfway done with the same.
Yeah, 43. Started at 1.
What's the speed? You know?
It was 195 per second, and now it's fluctuating between 4.8 and like 7. That's what I'm saying. I'm saying every now and then it like dips down to 3 on it. I'm gonna start really slow.
Alright, I don't have any burden environments. Actually, you know what? I have this DM. Look at this DM in front of math. That's like, why does it have this? Oh, it was
I was gonna say, I'm pretty sure he was just gonna copy files from his computer, and then
but he has a folder on the folder on
yeah, and then SanDisk over for it, because and then he got pulled into a meeting, leadership meeting. He was like, I was in the middle of something, guys.
Well, I'm gonna fix everything out in there here and create everything. And you have one thing that we didn't have was the sync installer itself.
Oh. Oh yeah, the Rosario same thing. Yeah, it's because he wanted me to get that, and he didn't feel like waiting like 2 days on NCSU Wi-Fi for it to download.
Yeah, but
Yeah, you should go to the WPI library. I tried to download it in here. Yeah, I tried to download it in here when the first thing that happened. Windows 10 said no.
just so you know.
It went from like a couple minutes to a couple hours, a day, 2 days, 4 days, 6 days, and then it just stopped the download because it was like, yeah, no. It was like, yeah, after a week of downloading, no. There's one on Founders Drive. It's Sunday.
Every single time.
It's Sunday.
Freaking Sunday.
It's Sunday. No. I can't get the Lord's chicken today.
No more chicken.
Yes. No. Okay.
We got cameras.
I saw. Yeah. I just realized we're on the stream saying that. Yeah, there is.
No, it's not live audio.
Yeah, there is.
Yeah, it is.
Oh, I'm sorry, guys.
I was gonna say there's people asking questions in chat earlier, like, oh, what programming language are you using?
Well,
What?
No, I was looking at the chat. What are the two section of things above the 330s?
oh, those are.
They suck in the air so you don't breathe it and it melts in place.
Yeah, like PLA actually has any bad plastic. It does. Better safe than sorry, alright? Better safe than sorry.
I don't. I don't think that's for us, is it?
It's the whole team briefing, so I mean, I could go. It's not gonna be in here. That's where all the streaming stuff is.
Oh, it's gonna be in here.
Yeah.
Oh yeah. Well, I'm already in here. Cool. I'm glad. I'm so happy about that. You know, it's my favorite thing to do is just to give up all the space that we have.
I mean, I don't know where the 12-volt batteries went, but I can go get a car battery.
The 12-volt battery. There should be in that big wooden box with the charging lights on the Make sure that we got one that's already green though. Check the charging lights in the front. Are they all just charging? Do you have a USB cable, or is that the
You what?
we need the USB cable, the white one?
Oh yeah. So other than that, everything else should be easy.
Okay, if I do royalty free, not royalty free.
Hey Joe, do you know? Can we sing like non-royalty free music? As long as we're not playing their audio? No, just sing it out of key, because then it's technically.
Somebody come on. Somebody fire burning on the dance floor. Oh wait, Ethan's
Yeah, that's why I threw it at you.
Here, you want to take one of the cameras and plug it in? Da-da-da-da?
Yeah, good job.
Da-da. I'm going to take the special film right now.
You want to plug in the robot? I thought you were. You're done. You're done with it, but you're synced up.
I am?
Yeah.
Should I plug in the camera first?
The driver's station, you plug it in, see if it even shows up, fill out the, you know, it's 6,000 volts, right? So see if it even shows up.
It should show up as 6,004, but it should be able to. I think we can flash on the people's screen.
Oh yeah, communications are up.
Yeah. Nice.
Alright, last warning is about,
I don't need to get virtual box.
No, not at all. You follow the instructions online.
Okay, I was just making sure I didn't need to do that.
There's even a .txt file in there for the robot part.
Hey, I
It's on.
It says install. I was gonna say, like, do I need to open it up in a virtual box or can I just go straight on the desktop?
You can do it on your desktop. Please install it on your desktop. Do not install it on the virtual box.
Are you sure?
I'm absolutely sure.
That was just for the stream.
We're going to do more on the virtual box on the screen. Oh, that's interesting. More than button 6 out of it or button 5 out of it. Oh no. Just trying to button out of it. So hard.
I trust you, but I need something finished, David. Do you understand?
What?
We've all sunk a lot of money into this. We need something finished from this so that this club doesn't die.
I know. And I'm saying, if you just trust me to deliver on that, then I can deliver on that. But if it's like someone has to look over my shoulder every 5 seconds to make sure that we're doing what you want them to
That's
do,
absolutely
it's
not what I'm
gonna
saying.
happen.
That's absolutely not what I'm saying.
I know.
What I am
then
telling
why
you
is it like?
but there is a process in terms of incremental value that we need to deliver.
Hey, everyone needs like safety glasses on. We're technically enabling a robot.
We know we're not.
It's
Technically, there are some safety glasses over there that
I mean, according to FRC,
There's no one in here that doesn't have. Oh, Ash Dosh. Oh wait, no, I don't. It's stupid. Never mind. I was like, oh, what's it?
Based on last night, we definitely should.
Dude, just let me walk with it. I think there's a misunderstanding. I think he agrees with what you're saying. He just doesn't get what's happening. You know what I mean?
Yeah.
So I'll walk with him.
Well,
I'll show him where we're at.
he likes to talk. He likes. I don't know how many meetings you've been in with him, but he likes to like draw everything out and go through every single.
yeah,
That's why strategy took forever.
I get what you're
yesterday.
saying.
We
So
don't have time for
here,
it.
you get started on and making sure that our wiring is
Yeah.
up. All right. You take a team, and that's you. I'll make sure that I can talk to Ninja, I get Sam on the same page, and our manipulators are made.
David, I'm stealing you. You're not going to be part of this briefing. If that's okay, we're going to.
David's like, thank you so much.
Can I have the
man."
ball?
Yo, we need the ball. Okay.
You like
Is this? Wait, is it supposed to have phone?
Yeah.
Oh, okay.
I don't like that ball.
Look, it's what we have. We're gonna do
This
it.
is a lot. This is not the same.
How do you know? Have you
Yes,
touched
my
it?
team has one.
Oh,
It's
okay.
not this squishy.
It's like the 2016 ball.
Yeah, it's like the 2016 one with like hard foam on the inside.
Okay, but it's the closest thing we have.
I was about to say, it's the right size, but that's a lot.
We're not, for our strategy, we're not actually shooting into the high ball, so it's not like we need it to be as hard.
We don't need it to be that hard, but intake will matter.
If it's 7 inches, then we're good.
It will matter for the intake, otherwise the real balls will like kick off the rollers. So
It won't matter because we have guides. Because the elasticity will hold it in place.
okay.
I mean, yeah, it's gonna be fine.
Okay, cool.
Oh,
We have everyone. We have a 10 o'clock. Who are we missing? That's here.
If they're not here, then they're not missing. Sam.
My guy, we need to have enough people to run this thing today.
You're missing Sam.
Sam missing Sam.
Yeah, I'll walk with you after.
No, I trust you guys. There is an incremental process that we need to be delivering.
I think David's kind of
Stress. I understand. But we need to deliver. Yeah, I understand. There's incremental things that we need to deliver just so that this thing looks.
so
there's value.
It's not FRC. I think he fails to realize it. We just gotta kind of talk that out.
Understand.
Like,
But it's important for all three of us to be on the same page, so that
So I'll get you on the same page first.
so that the rest of the team can be on the same page. Do we have for the rest of the team clips? We're gonna pass can we just use an omnidirectional mic? Will that pick that up? Can we just not have to?
So if you stand over here, we'll put the camera at you.
My question is for the rest of the team.
Yeah.
Will this capture
This
everybody?
will capture them, but you can't sit over here with the log on.
I can stay.
Also, keep in mind that camera's in front of the other camera.
Okay, wait, no, then that's fine. I don't.
Yeah, just take the law off. Just take the law off. It's fine.
We have the omnidirectional mics. Make sure that's picking all of us up, and we'll be good. All right, guys, we're running like a minute late.
We're missing our operators.
How'd y'all sleep? Y'all get sleep?
Slept great, honestly.
I slept 3 hours.
Sleep.
The program is kind of slow. I mean, well, he gave us.
Thomas and I were working on getting color and stuff, and he pushed his code. And stuff.
We've got sensors
I've
now.
got grip started going on for as well.
Great.
Yeah. I don't have the network cables component, but I have everything installed on my computer so vision. So that's where I'm at. I also have a working driver station on my computer, so I can also do stuff as backup. Can I just run across you? Do you guys know any other people coming today? Just off the bat. Any other people coming today that you know personally?
Would also be here soon to help you with. He said he's running a little late because he's doing stuff for the team mentors, but
All right, fantastic. All right. Hey guys, thanks for being here for day 2 of Robot in 3 days. Can I get a whoop whoop? Oh my god, y'all died. Kill me. All right. So the plan is we're gonna run through all of the build leads, give us a quick retro on what happened yesterday, and then I'll run through some housekeeping, and then I'll run through the plan for today, and then you're gonna meet with your build leads or leads in general to figure out what the rest of the plan is for today. We're gonna try to keep it as short as possible so we can get down and running. So sound like a plan? Okay, great. So let's start with sort of quick retros from all the leads as far as what happened from yesterday. So I'll start with build. Build, could we just 10 seconds, like what happened yesterday?
Sure.
How do you feel about that?
So we worked on the chassis mainly. We got the chassis built and run. Just
Talk to the mic. Yeah, sorry.
so we got.
Let to the room.
So we got, so we got the chassis going. The only stuff left is mounting the electronics, which we're about halfway done with that. And we got a intake kind of designed on CAD, and we have started prototyping it. Same thing with our ball eject. We have it on CAD. We just need to start prototyping it. And the climb we have ideas for. We're going to get CADing on that in the morning, and hopefully have a prototype towards later in the day.
Fantastic. Programming?
We programmed the chassis. Now we just need to test it on the chassis and then start programming the new mechanisms.
Okay, cool. Visual media and text media, you covered both.
Yeah, sure. Text Media published a couple blog posts yesterday. Visual Media recorded a lot of footage. We're literally recording right now. And we're working on our intro for the videos that we're publishing today. We recorded 2 tutorials of programming and a couple of other videos that are going to go live this morning. And we're going to rebroadcast those across the stream and put them out on social media and everything. So we're on track.
Cool.
Thanks for working with us on all the footage stuff.
One thing I will request, a lot of what we're doing will only be valuable with all of your support in terms of getting this out there to people. I mean, if nobody sees what we're doing, then it's like if a tree fell in a forest, did anyone hear type of thing. So let's try to get the word out. We've done a lot of amazing work amongst all of us here, and trying to get that to other people is going to be really valuable. So Sam will be on that to try to make sure that you guys are able to help spread the word to make sure that people see the amazing work that all of you guys are doing here today. In terms of it, go ahead.
Oh, I was just going to say, and also today, as you guys are prototyping and designing and playing with things, if you're doing something cool and we aren't getting a video of it, fix that. Come find somebody with a camera and say, oh, hey, record this. Alex, Hunter, get Pavan, Kaz, anybody who has a camera, a good mic will record you. We want to capture the prototyping, we want to capture the cool stuff, so make sure that we do.
Okay. One last thing I want to thank the people behind the mic and the stream and the cameras. They're not going to be on this tape, but want to thank them for all the hard work they're doing to help us from there. And let's just give them a round of applause. All right.
You sound very good on mic. I'm sorry.
Well, and then so administrative items. I have 3 administrative items that I want to run through. Food's important. Everyone wants to be well fed. So as part of that, we're going to make sure we're going to do another lunch run today. We're going to do for dinner tonight. We're going to run through our what we had bought in terms of chicken nuggets and whatever else was there. And then I'll probably order something something for delivery, probably pizza. We can all pull together and grab. So that's dinner. Attendance. We're not taking attendance, but if you guys are here, I need you to talk to your build leads. If you're gonna leave. discuss the specifics right after, but just like the way, just the process what I want. So that's good, and then the
One, it may
maybe 2 different programs he wants to do today. One about programming a drivetrain, and then later tonight when Thomas Barnett gets here, probably a programming about how to like different colors for the field and that system. So can you work with them on that? What's your availability today? Okay. Can you work with him on doing this for the most part this morning? This one? Yeah. They'll be live and recorded. I'm trying to get you the drive as soon as possible. Sure. If you want to do that and move everything, that's up to you. Just the computer. Yeah, that's fine. If that's easier for you, and that might be easier, we will want to probably strike the lights so we can light them in there while they do it, like at the table before. But yeah, if you can manage that, then that'd be great.
I mean, we could do it in here. Like, but I put my laptop there. And then, yeah, that might be one of the better ways to do that.
Sure, and then you can either lock him or you can talk him to him again. Okay, great. Thank you.
Okay, cool. I will get up with you about that in a little bit. I'm going to kind of figure out what the plan is for us.
Our traditional 2017 style shooter that enables us to extend the hood out that way on the hood now. Well, what that allows us to do is put it on wide and design out the hood system that we can tells us that, hey, if you were to take this hood out and change the gear ratios and potentially modify the fuel a little bit in location, you could get the higher load with this gear.
We might do that later.
We have a little talk that
It's yours. You can also do it later.
They'll figure it out.
on the side or a little bit. And we have something that goes on the top of the road.
get what they're doing. They didn't let me pull off.
And then once it's a mechanical stop, so you have something like that.
It doesn't necessarily. One thing to keep in mind is that when the intake goes out, right, you have to have a way so that you can still hold that intake back in. You don't. You don't. I mean, we still. You don't. Play over it. Yeah. You got one.
Well, if we do it where, I'm just saying, if we had something where, if we had something like on the outside we have a gear and then another gear, and the smaller gear connected to a wheel that counter-rotates. So if you run into a wall, the counter-rotating wheel will push it up the wall.
It's easier just to kind of. I mean, we're gonna have honestly, we're gonna have a system to kick it out anyways, so we'll kick it back in, right?
Yeah, I was also going to say that you could do something like that.
Yeah.
If you ran into a wall.
If it was on and I'll get it back to the regular. Like that's the easiest problem.
Yeah. If you're getting it in and out of the printer, it's just based on where you put the bits. Yeah, you're based on that right off. Yeah, right. I'm saying that whatever you feed into here to go up, it has to be dimensionally placed so that your intake, when it comes back up, isn't hitting it. Yeah. Including when we have
And
full balls.
it
That's like
can
the
go
other
over,
driver.
it can go over. The intake when it comes back in can go over the stuff like that.
Yeah.
Because then you just put it down and go. But it has to be, the whole robot at some point has to be less than 1.4.
Yeah.
Which is why it might not be quite straight. You might have to put a little bit of a curve in there, but it's probably it's fine because the elasticity will carry the ball through.
Yeah, it's mainly just.
Yeah, but
what I was mainly suggesting was using those pulleys, like the pulleys.
yeah, I get what you're saying. That's fine. I mean, we can design that when we did that prototyping phase, but as for you, none of this matters unless you have dimensional reasoning. Like you're saying, we gotta lay it out. We gotta know what's going where. So I need you to get that. Yeah.
And then, who has ideas on intake slash years? So you kind of need to follow system kind of ideas.
I was having an idea for taking the stuff that is coming.
How would we do in CAD? I live on that.
The main thing is I need to see how much distance it
Yeah.
is between a wall because it's a different type of metric in terms of that.
Yeah, so you and someone else go work on that. I have an idea for one. I just gotta do a little bit of research for it actually.
Yeah. You didn't do anything.
Also, I was looking into something last night for the actual, for the control mechanism. It was like a kind of like a gear, but it had curved gears on it that we extracted the area between the pinions.
Yeah, I know what you're talking about. We don't really have a machine tool to get that.
No, what we're saying we would laser cut it. Out of the material.
Yeah.
And then we just drill the plates together, the sheets together. We have cut holes and we.
Sure. We can drill onto the program. We base only once we have dimensional, because we don't know where we would put that. So you've got to get that. Like, that's your number one priority. You got to get that going. Todd, before you work on time, you're gonna maybe keep saying this, but we've got to have a control system ready to go so I can give you that.
Yeah, no, we're waiting on the bolts. That's
Right. We can do everything else and get wired out. Also, we know where this is going to go, so we can get our motor controller mounted as well. The PCM is going to go right here. The manifold goes here. We can talk about that later. I'll help you out with electronics. That's going to be our job today. Or not for the day, until it's done. Yeah. As for Sam, and I'm going to put Carlton on. Are you okay with doing CAD again? Yeah.
You guys like have an actual robot?
You're really fast on CAD, that's why. You got a few questions for that? Okay, so program one. You two are going to work together to get dimensional reasoning going on here. Cool? Alright. We're going to put Sam and Anna. Anna, I need you to be, again, off your picture, but right now I don't think there's much fingerprinting going on. So I'm going to put Sam and Anna. Basically works on getting that intake to a closer point control. If Jamal's not here right now, what you can do is get to a point where, we have to be able to test the ball rolling in, and I want to show that in media. So, how about we do this, right? Let's make media happy. Put a drill to this. Just get a drill that's larger, half inch, right? Spin it, have it held in place on the other end so I can vary it, and see if it actually stays. With the ball coming in. Yeah. If you know how to do it, then go for it. You know how to do it? No. I mean, I can't. Oh, yeah, we have to wait for the bike tire. In the meantime, the bike tire will have the grip. In the meantime, test it with that. Then, do your run, get duct tape, see if it improves. Because we can always get the duct tape off, and then once the bike tire's on, you're going to do that. So that's what you should be doing as far as the right? Okay, cool. Congrats, you guys. Yeah.
Yeah, they also said it's not like what the actual one is.
Yeah, they said the actual one wasn't or as much. Or, so we need which drill did you get?
I don't care. Honestly, I thought about putting one in my dorm room.
I think that one takes the smaller battery.
You don't have to drill in your dorm room? Did I get everyone? Does everyone have a job? And everyone has a set list for what they're going to do?
Two burger spin-offs.
Working on
best way to do this.
Yeah, this is gonna be the right one. Yeah, we need something sharper.
Okay, so let's do that. You want to work on that? So that we're basically waiting on the electronics. We're waiting for Velcro.
I'm not sure. Literally just.
They told me on Friday to save them for now, but I don't know if that changes.
Yeah,
I've just been throwing them all back in the box.
Yesterday, I think they said they were trying to keep track of the gearbox stuff, but now that we got the major gearboxes built, then it's not
Compressed down to that
as
size.
big a deal.
that's
This
what I always
bearing does not fit in here, so I guess we might go to see.
What about peak maybe?
We could use this and drill a hole out, so we could just find the different pieces.
You won't be able to balance it. You have to have something sturdy.
I think Dave's in our
Otherwise, you're literally just.
I like the 148 so that's easy. It's just 4 bar push up, and then that folder gets them back down or back up. You know what I'm talking about?
Yeah. I'm trying to think. We have. Those are very random. That's what's very
If you think it needs to be, we could run these on
Yeah.
and at least they would be consistent about where they, like we would move it up and down in increments.
Yeah. How far is it?
How far do we have to be up?
Where is it? 6.6. Yeah. So that'd be like right there. We could just try that one first.
Yeah. Let's just make that one bigger.
Alright.
Are y'all gonna use this piece of scrap? Cause we're gonna drill a hole.
Gonna use this?
Hey, go for it. It's all yours.
We need this. I forget what they're called. This is Alright, let's start doing something together.
You want some videos?
Yes. The reason I'm asking is they use some of these. Hey, when are you gonna be ready to test the leads?
I think Matt brought it. There is Velcro in a box, but don't damage it. It is something.
We need those. Yeah, you need to look those. What do you need next?
Wait, he's building a climbing testing.
I know we have one.
Climbing first.
The problem is where it is.
It's on in here.
Susan first.
Whoa! I'm hearing different things from you too.
Wait, Lazy Susan first?
Yeah.
Wait.
We're
Why?
gonna be ready to test the lazy Susan. Which way before we have
Because you're working on intake right now, right?
Yeah, we're working on intake.
It's gonna be faster. Yeah, you're gonna be really. Yeah.
Okay.
That's also one of my.
On some intake stuff and some electronic stuff, give you an update. Would you want that?
Yes.
Okay. Yeah.
Let me get a camera and a mic.
All right. Cool. Thank you.
You record?
We tried it.
I wanted the sticky kind.
What? Where's the step bit, Tom? What? You know where they put the step bit last night?
It's in the metal box in the bottom of
The middle, that one, and the very bottom inside of a box.
that little metal box.
Paul, I got a picture on something.
You got what?
I got a picture on something. It's crunch time today.
Yeah, I know.
So, all right.
We gotta make sure we don't get it too big because of the flange.
Yeah, that's true. I did put those on the list. So.
We have this one.
Yeah.
It's a Velcro?
Yeah, it's not sticky kind though. I was like, what do you guys put it? He said it's in a box. start working on what?
Okay, so I need these things to be filed.
That would probably make sense.
That's the thing. Yeah.
We should probably try to go for one and then waddle it out some maybe.
That would make sense.
That's this housekeeping.
Yeah.
That's great.
Written down here.
Written down here is so Tuesday.
Sounds good.
What are the things we need to get done right now?
Okay, so they're moving along.
Deadlines for all this, so I'm not putting it back in the head. Just so that we know when to come and check it. I don't know, people say this off, I don't. Please do that. You're fine, I can give me deadlines so I can come in. Okay. Sam, similar things for you. Just I know you're here.
Yep. I'm gonna have to go. You're gonna work with Colin.
Alright, sounds good.
Just zip time.
Yeah, don't do that. We'll make it happen.
That's Josh. Who's the second person who's talking?
Who's my second person who's talking?
We're gonna stream this and record at the same time.
I didn't have a second person.
Do you want someone on Instagram?
What'd you say?
What's the range on the mic?
Well, we're gonna be recording everyone, but on the stream it'll be whoever has the mics.
Okay. We don't need a second. We don't need a second person. Okay. And I'll get Eli on it.
We'll get through that. Okay. We're talking about getting closer so we have to run extensions. Well, we can put at least two underneath it, so you're not gonna fit.
Right now,
Okay. So at the moment, what we're going to be doing is giving you guys an update on what our build is and what we're going to do for the rest of the day. Mainly this morning, we're going to be working on getting the chassis up and running, so that way we can kind of have the programmers test their acceleration codes and kind of see what our dimensions look like, so our manipulators can start getting put on the robot. Speaking of manipulators, we're also doing some basic testing on the intake, and CAD is being heavily done on the shooter and our climb mechanism at the moment. I'll take you over to the chassis right now. Excuse me. So our chassis here, as you can see, we're basically working on mounting electronics. We decided that we want everything as low to the ground as possible. Our battery's going to go there. This is actually the front of the robot, and the reason we want everything low to the ground is so that we can have the ball come in and go through, because we're going to go basically through the robot to store all the balls. As far as, we got our belly pan in yesterday. It was kind of a late night, so That's kind of what we worked on. I don't think you guys saw the belly pan yesterday. And then we also have figured out how we want to figure the problem out with these pneumatic pistons. So we were deciding that we want to buy a T that would go in the middle of here, and that we can kind of just split out and go straight into our pneumatic manifold. There was a problem getting the smaller dog pistons that are generally with the gearboxes, so we kind of had to do our own thing, and it gave us a little bit of a problem space-wise, but we're working around that now. Then if you come around this way, I can show you some stuff that's going on with the intake. So the intake here is, we're basically on our second prototype of the intake. We're going to use a roller with something grippy that will actually grip onto the ball. And then we're going to angle the rollers like towards the middle so it funnels it. It's kind of similar to how 254 did their 2016 robot. So we're going to test that hopefully later today. That's what the intake group is working on. We got a game element, so that's great. And then we have catters over there working away, but that's going through the programmers. That's about it as far as this morning. Hopefully we'll have another update to you around lunch. All right, that was annoying.
Yeah, all of the can.
I'll write you down. When are you available?
I have to check my schedule. There's and I have to check it at 11 because I have to figure out the parking lot. Okay, cool. Yeah.
But you will be here tomorrow at some point?
I'll be here tomorrow morning. Wait. My first class is at 2 or 1. I'm just gonna stay until the class is 2.
Your first class is 1 or 2?
Yeah.
My last class is like 1, ends at 1.
I have a lab in the morning, but
You shouldn't have a lab in the morning.
yeah, no, labs won't meet, so.
Make sure you get the trip. Okay. Yeah, somewhere. So I put it already. Yeah, do it right here. Just do that. Any of that stuff it most of it does, but that should do most of this one. Push that a little further so you don't have to. Alright. Yeah.
You know how we had the idea of sticking with shooters that was here, intermediate fuse, but it was still
Sure, but yeah, however you guys want to do it. As long as we need to
Right.
so you're giving back to that. Yeah, you guys still have like design law for high 11, so you can like each of the things design from proper strategy down here. You know, and you have this new I'm just trying to fill stuff in check inserts also.
Okay, so and before we try the whole wraparound thing, and then it comes out and shoots it out. Although it would keep us from having to read these big balls and then drive down and realign kind of thing.
I don't want to
It's kind of, it's going to kick us out, right? Because when we have your designer shape, our whole concept would be very thin and it kills us.
So
and
wait. So we should get this first. So you're probably using
No. So if you were to do this design, this beat is all the way. So these are all around. So it was the overall for each that goes out here, right?
I don't think the electronics.
So this is the right, right? Yeah. We have to take the ball, and this is nothing. This is the path the ball takes. Yeah. But the ball goes in here, and we have a polypore thing that we wrap it around, and we go feed into the shooter here.
Hold up these though.
Yeah, we don't buy it. That's always
Yeah, so these are types of performance that I'm talking about.
Right.
They will hold 5. Like
You know the strategy document that you read yesterday? That was kind of what we based our design on. It's like whatever that was required in our strategy yesterday, like those are
right.
really
Like,
possible.
you can write those down.
You're loosening the nuts.
I don't want to create too many numbers. Just like
I know what you mean.
write those down. This will all speak to I created it. He said the things that he said we're going to do.
If you were the strategy meeting, I want so. Let's see, spot really rolls. Let's actually do.
Can we just write out workshop it? You know, let's just go through all the requirements for each of the things. Okay, so
Yeah,
same thing. So ball points.
Because then we can write our deadline.
Let's call it ball delivery.
Yeah.
I'm gonna record this. This is good.
All right.
Hey,
All right, Ashutosh, let's figure out what our plans are. So ball delivery, so requirements, able to hold 5 balls. I'm gonna do the easy ones. Climb, able to climb in 14.5 seconds, I think. I'm gonna need to go grab my laptop. I'll be right back.
You building field elements now? Yeah, he's gonna work on it.
you like this?
Great. All right. You guys did mine. It's not hard to meet.
Alright. I can do everything except probably the PCB motor bolts.
Oh yeah, I expected that. I meant everything but.
Yeah, okay.
Yeah.
It might be a little sloppy, but we're good.
Yeah, just make sure that the cables don't like feed into the gearbox or something.
Do our best.
You got it.
Do our worst.
That's not what I expect.
Plenty of switches. Yeah. I mean, that's. I don't think 2 inches higher is going to make too much difference.
Yeah, not with.
Well, I mean, we'll have to build a shooter above all of this anyway.
Yeah, so we would have to drop it down.
Alright.
Okay, so. Sure. Great. So dump 4A is what we selected. We need dump 4A right here. Cycle time. Okay, end game. Cycle climb. 14.7 seconds for the climb.
Yeah, it does actually need to be elevated. It does need to be elevated.
So it's 14.7 seconds on your list. For our list, we're saying with the mechanisms that we're looking at, we're hopefully going to aim to do it in around between 8 to 10 seconds.
Okay, sounds good. So as long as we fit the criteria, we're good. Okay, disc rotation. We need to be able to do 2 things. We need to be able to both rotate, both rotate the disc 3 times, so meet the rotation requirement.
Yeah.
We also need to be able to detect the color and stop on a dime. So encoder, whatever those design requirements mean, that's what we're looking at there.
All right, sounds good. So that is what our plan is to do right now. Okay, yeah, that's our plan for right now. So That one I think is pretty straightforward. I mean, just accomplish the mission and you got it.
Sound good? So, and then for ball delivery, let's go back. And then you're going to talk about the, we're going to need one more thing. We're going to need chassis on here as well. Pause for 1 sec.
It's not a material, but these are 32 inches.
See what you can make work, right?
I don't have anything that's 32 inches that's wood. I have the
Worst comes to worst, you might be able to chuck the drill on the
Okay.
and all the wood I kind of want to use for
Like fair, like a fair.
Yeah.
So I need to make that work.
Can you like,
probably, yeah.
which has,
I mean, that's meant to go
sitting.
in the drill. Yeah. Yeah, that's the depth we need. Go for it.
Can you check that first?
And 2 3x3.
And then if not, yeah, because it might be Okay, fantastic. So chassis. So we have a few requirements for the cycle times of the chassis. Let's see. Okay. I guess some of that information is gone now.
Okay.
Well, we can talk about chassis later, but basically we need to be able to go fast.
Yeah.
For ball delivery, we need to be able to deliver the ball. Do we really not have any of the numbers?
No, you had it yesterday. I forget where I read it.
No. It's game rotate, climb, park.
We want it. Where do we want it? Right here. I was saying something like that. It might be easier to do it here.
Okay. Anyways, climb by end of the match. You need to be still hanging at the end of the match. Double check that requirement. Look in the rules. Make sure that whether or not you need to be still hanging, or you can down spool after the end of the match. Check that because that could make your design easier.
We have a ratcheting gearbox already, so we're gonna use that.
Okay, that's fine. And then as far as ball delivery, you need to be able to hold 5. You also need to be able to deliver 5 quickly.
And the efficiency was you'd be able to deliver 5 of 5, right?
5 of 5. All 5, because we're dumping them. We cannot miss.
We can't miss, basically.
We cannot miss. And we need to be able to do that quickly. I don't remember the numbers off the top of my head. You know what? I'll be right back. Sam has all of these numbers.
It looks really nice if you do it. Like if you do it like in this space.
Oh yeah. Wait.
Or something like that.
Wait, no. Well, hey, for the past 2 weeks, we were looking at putting boards right here, right?
What did you say?
Just for like ease of what we were looking at. We were looking at putting like just one sheet of Indiana across the side of all the holes, right? There's one of the marks right there. At least for like 90 everything except this. But for the other thing, that's too much stuff. Yeah. Honestly, maybe we should put it like that and have one side of this, just like some.
Do the electronics on the outside, you're thinking?
Yeah, and have the electronics on the outside. But do it once.
I mean, well, we can keep these and do the PEP and everything else on there. But
I mean, the battery goes here.
Well, yeah, no.
That's
Just for the sake of time, because the chassis does need to be done, we can't wait for David to come back and use it and just get it now.
yeah, okay.
If it's really, really bad, we'll move it, but as of right now, we gotta get this chassis running.
Okay, cool. This is let's talk about deadlines. What are your thoughts? I don't have all the requirements. I'm gonna come and update this page once I come back from Sam. Let's talk about deadlines. What's priority number 1 is ball delivery for me. So let's write a number 1 right here. Priority number 2
is climbing. Let's do that. Priority number 3 is disc rotating.
We're down to
Priority number 0 is casting. So 0 there. This is used for camera. Ball delivery. Deadline. When do you want me to follow up with you? It's not deadline for it to be done. Deadline for check-in.
Yeah, you can, and again, if I get bad about media, you can tell Sam this too. I don't know.
Can you just wear a level mic at all times? Like,
I don't know if that's a great idea.
it's fine.
But
Good for video.
not always. So intake 6 p.m. Sunday is when I'm thinking we have this intake
Ready
not
to
only
start.
made but
I'm talking about both intake and delivery.
right. So the intake, I'm saying that it'll be on by 6 p.m. today. I should have enough for it to actually be put on the robot. It's moving along much faster than I'm happy with it.
Okay, fantastic.
Oh,
So
they're about to test it and put it on video right now, actually.
Great. Climbing.
So,
Climbing. What are we looking at?
climbing, we have we're kind of on a halt right now because of the lack of people. But once Todd is done with,
I just need an estimate for check-in with you. I guess
Yeah.
6 p.m. is the first check-in, so
Right.
can we get a check-in before the design meeting?
at 12.
We might scrap the design meeting from what I'm hearing. Like I have a rough idea of what we're doing, and they're.
I don't think you really need a design meeting right
I
now.
don't think we need a
There's not much else I can present to you other than what I'm talking to you about, right? So can we just do this thoroughly because that way we're on the same page,
I
and
need
then
David to be on the same page. David's not here unless you can get.
I'll get David on the same page.
Okay.
Yeah.
I still want some rough design meeting just for the video, so maybe 30-minute design meeting. Just we'll run through all of this core video in a video structure.
Okay, but at least if us two have this, then it's going to be much easier, cleaner, and everyone's on the same page. Sounds good?
So climbing.
Okay.
A rough sense of when I can check in with you.
Climbing, so as soon as Todd's done with the electronics and we're done here, Todd and I are going to move and work on climb. So that's kind of the first time climb is actually going to get some action as far as building goes. We only have ideas at this point. So I would say as far as climb, where you would check in with me, it would also be around 6 p.m. to see if we've actually made progress.
6 p.m. Okay, let's write that down.
So 6 p.m. we have it fully designed and we have plans made to put on the robot. Does that sound good? Because it won't be done by 6 p.m.
It won't be done. Yeah, of course.
So
so let's do 6 p.m. there. Can I get an intermediary time? 6 p.m. is a really long time from now for ball.
Yeah, you can check with me at any time. I do not mind.
Okay,
so if you feel that
right now, how about 2 p.m.? Can we
sounds
get a 2 p.m. intermediary check-in?
Yeah, sounds good. Make sure we're making progress. Yeah.
You want to write that down?
Yeah.
I'm just gonna take a picture of this.
Yeah.
I know what I'm gonna set myself reminders to come and bother you guys at these times. Cool. And then disc rotating. So nothing's been done at all. It's gonna be kind of back corner, maybe Monday, but let's set
let's at least have a plan for it by the end of today. Sounds good.
Plan by end of today.
Yeah.
And again, I might sort of advocate for that idea of using ball delivery to be able to do disc and things.
I think that's the way it's going to happen, but until we have this solidified, I can't really.
But keep that in the back of your mind for the people doing ball delivery because you're going to transition to climb.
Yeah, and I've already talked to them and said that keep in mind that whatever ball delivery system you use, it kind of is going to double as a disc rotation. It's like we can't use certain ideas. Yeah, of course.
Fantastic.
Yeah.
And so chassis, what time are we looking at for this chassis to be done?
By
this
lunchtime.
Will be useful for
by lunchtime. Has to be done by lunchtime. Done by lunch.
So I will check in with you in an hour. It's 12.
Yeah, I told them that their electronics need to be mounted around 11:20. So.
Okay. So I'm going to check in with you guys at 12. Sounds good?
Yeah, sounds good.
Okay, we're on the same page.
Yeah.
Let's go for this. We got this. I will stop bothering you till the first deadline.
That's fine. I'll take this.
Some reminders in here.
Right. And then I'll keep updating this list as more people show up and put it on.
Okay.
Yeah, that's about all I got.
This is all your. Okay, so this is Monday.
This is all Monday and Tuesday. As far as Sunday goes, what you see right now, I mean.
So the responsibility. So all I want to say on here is I'm going to get this in a spreadsheet, and once I have this in a spreadsheet, responsibility is on you to make sure that we have build going. You and
all
David,
the time, yeah.
All the time. So I'll set this up
in
a spreadsheet. Once I have that, I will get back to you to see where our gaps are, and you guys can work.
Yeah, that's fine. Yeah, sounds good. Cool. I'll keep coming back to check with media, but it's not a good idea to keep this on.
We're looking for
All right.
zip thing.
Those bolts.
At Thresh Time, where's the churro? Can you run David through that?
Yeah.
Where's the Thunderhex?
We had 2 pieces of churro.
Oh, this one.
Yeah, same as.
Look right here.
There's a quarter 20 volt. There's a quarter 20 volt fit to this.
No. It's not RP. Here, okay. Until we get the bolts for now, this.
Go ahead. You can go ahead and mount this side. Yes. Well, he was saying wait to do that side.
Do this right now.
Because that's
Honestly,
that.
this thing is fine with 2 volts. Todd, you can mounting this.
Yeah, how we looking?
Not good. It's literally zero progress has been made since we left.
Oh,
Yeah, I'm just wondering.
You guys need marks? Yeah. Let's redo it.
The design is
Apparently they did not get water.
what's changed?
Where's the low slice? Yeah, I didn't even know that existed.
It's gonna loop around, figure it out.
So we gotta go back to the
Not right now. Zip ties are gonna hold. Hawkins down.
Yeah, we're talking about
We'll just fill everything with hot glue. We have Velcro, but not really. It's not adhesive Velcro. So you can Hawkins Velcro down.
It's literally just a roll of carrying the robot blocks, so you have an idea of what's going to go where. Because right now, I can't tell you.
Are you the one who bought the milk?
So he's doing dimensional reasoning. But to an extent, he's blocked, so we at least know what's going to go where. Right?
That's encouraging.
We're thinking about this. Is it low temp or high temp? This is your robot. You're going to take a loop bumper and you feed it into one close feed. Do you think it's enough heat to then
Not the way I was playing. It's just putting it like straight. We can kind of do this and make sure it's time.
because the elasticity will still make it.
We should be at almost 5 this morning.
Yeah. Isn't that great? And then we have a problem right here. Around this is where we'll put our.
We need to have a combo climb and wheel. That's going to be very easy. I have a very good plan for that. I think I'll probably just do it. 24 hours from noon today. Build these speed dumps.
So the climb is going to go over around right? So
Half inch, 3/4.
That'll work. Where?
He is gone.
Yes.
A programmer has volunteered to get some code into the time.
Yeah, I know. We already know the strategy of the climbing thing.
Yeah, that would be.
You're not touch that at all.
Yeah, no, I already told them I can't give you.
Actually, yeah. We're not giving, no, we're not only not giving people. Where do you guys, where do you guys want food from? Where do you guys want food from? We're gonna do one place.
One place? It doesn't matter to me. I'm fine with that.
Yeah, you guys come up with one place. Just tell me where you're going.
So many episodes.
Do you know where Star is? In the close yellow thing. Yeah, it's the one that says shit. I guess it's called.
Alright, how can I screw this up?
How do we run this?
Find the wrench for this nut.
It's 3/8, yeah. What do you need from me? Can you speed up the heat of the hot glue?
Grab it. Grab a heat gun and blow the wall up.
Okay, so I can start connecting wires to places. Is that you're dropping that?
Yeah, we can get control system started going. We know the PCX got to go a certain way.
Yeah.
Is the PCX
That's going to be.
Yeah, are we working here?
I started the drill and he said hot glue.
Yeah, I thought that went here.
Yeah, no, I'm literally just with the seats off. I'm literally just going to put everything in place and ours is going. Is the PC Mars?
Just this.
That's the input for. No, this goes to the PDP. Yeah, it goes right here. So we're going to do longer cables for this.
the wire? There's a huge collection of it on the shelf over there.
Also a very small screwdriver.
We have a loop of it somewhere, right?
Yeah. Steal their stuff first.
Steal our stuff first.
Yeah. Okay, this stuff paid for by college students for the most part. Yeah, it's tight.
Alright, awesome.
Let's see,
I want to quite right. Everything's in such a bad spot. Hold on, let me get the bolt on first.
Yeah, because I don't want to go right through here, so I kind of have to go around.
I don't think they have what we need.
Makes things look really.
No, you want to go right through it.
They have like 4 band wires and stuff like that, so I'm gonna look for ours. Where's the Amazon box?
Now, all of our parts are under there.
So you're going to want to do.
No, this is not a live stream.
This is not Monday Night White.
Hey, we're in from Wendy's. Be alright with you guys. I'm right around.
Sounds good.
Great.
Now you pick the alt.
I didn't think of it. Alright, I'm gonna grab my laptop.
Some more cartridges. Is the hot blue hot? No. It's only one last. Alright, so I'm really done.
Alright, David, I'm going to work with them to make sure electronics are mounted. Can you do me a favor?
I'm getting everything right now. What do you need?
What'd you say?
What do you need?
The Intech group seems to be struggling. So if you
I'm
can...
working with the intake group right now. I'm trying to find group tape to get the intake group. The next thing that I'm going to have to do for intake is we're going to build something like that. So we can get that on there. Thinking that.
Thank you. You guys get a fitting from this?
David, did you get a pneumatic fitting? What? Did you get a fitting?
No, first step is inside.
Sounds good.
Hey, just put pressure on one side. It's permanent load here. All the pressure here.
Just input pressure in those two.
Yeah, that's okay. So we're only putting 4 down right now. These all have to be worked on.
We can't extend this then, so it has to be going right into it.
So yeah, we're gonna have to wait and see.
Yeah, just put 4 down. Because the rest of them...
Alright, the rest are gonna go right here. We'll all go straight to those. Take those.
You're gonna go on the base.
I'm gonna go right on the base, right here.
Yeah.
Where's our 20 gauge wire? We have like a little
Gas wall. It's.
I don't know, man.
The motor controllers are...
You seen the 20 gauge wire?
20 gauge. It should be in the same box. It should be, but it's not in the Amazon box.
That's the way they're configured on the one round.
No, that's not gonna be
Wait,
it.
what?
I'm sorry, buddy.
It's definitely here. I saw it the other day.
Yeah, I just think somebody moved it.
I mean, hey, buddy, it hurts my feet, but you really want to know the reason for yourself?
Yes, they haven't tested it yet.
Yeah, no. We only have one here right now.
Okay.
And he's working on a bit.
Alright, okay.
Where's 6?
That's good enough.
6 is over
We
there.
don't need the other 2 bolts. That's plenty good.
Can you grab motor controller 6? It's over there somewhere.
Catch.
So I have the software to read these on my phone. It's perfect.
Oh, Matt.
Here, I got it.
Oh. Yeah, both this and that. Planning. Did we ever get Velcro? Did they find Velcro?
They did. It wasn't adhesive. So they're not building.
What do they need to Velcro?
5689 works. That doesn't bother me.
Sparks
5691 works. Sparks can just be. Where the hot is it?
No, so...
But I'm not about the bag.
No, the glue's not there. No.
And I'm not going to use it to the thing. For what?
No, they're hot glue and Velcro.
We're hogging in the Velcro.
Hot glue doesn't stick very well to polycarbonate. You try it. I think the Velcro will have more strength than the hot glue.
Yeah.
I think it's just gonna be easy to just like
only thing is we can't extend the 3 phase.
Yeah, this one.
Okay, well, what about the one thing up here?
What?
Yeah.
These don't get matched. Remember? These get matched with the PvP. This one's supposed to go under the road right here.
Yeah, that's what I was saying.
This is what we discussed last time, right? And then
Yeah.
match these two here, and then all of the cabling reach.
Okay, remember it has to be accessible because the can is down.
It's super easy.
Yeah.
Well, so this can't go under here then, though, right?
It doesn't need to. It goes right here. Because this motor plugs in here. I think you guys are like way overthinking this. And then, yeah.
If you give me margin,
Yeah.
That was what I suggested.
Yeah.
Because that's what we discussed last
Yes,
time.
that's what I'm saying. Just do what we already discussed. I mean, yes. At this point, we just need to move in the direction that works.
I wasn't there for the discussion, so.
So are we building, is anything going to be built for testing climb or
Not
not?
very well. Now that he says that, he's right.
What?
Like the hangers from the field case cards.
Yes. Because I was told that was going to happen, but I guess not.
I don't think I've heard of anyone talking about it.
Alright, I'll finish that right now. Alright.
Yeah.
You do that, and redo.
Alright.
Let me double check. Where's the hacksaw? Does anyone know?
Should be on the floor behind you.
Yeah, floor is up there.
Dude, if you flip that over, by the way, that's a rough
What?
If you flip that board over, that has a rough incline for.
That's actually a lot worse than I thought.
Port band, dude.
Yeah. Colin, can you slide out that half sheet of plywood so I can pick it up? This one? Yeah. It's sunny outside, right? We're gonna open up the garage door. Go for it.
do it here? Look at that. Does this work? Is that accessible enough, or do we need to do it over here maybe? Why should we usually over here? It shouldn't. It should.
If I ask you, can you go able to
You have this full length.
if I ask you to plug in a candy cable, would you be able to
Just wherever you put it, make sure we can redo all the wiring.
Yeah. Well, we haven't even done that. Can I just plug in the cable?
No mail.
How tall is the bumper back when you think forward, please?
Is it 4?
Yeah, because we both have.
Can I get a rules reading on the bumper back? Is it 4 or 5 inches?
Is somebody responding to that request?
Price doesn't really make sense.
Multiple
Somebody needs to be monitoring this and making sure nobody enters or exits for that camera. I mean, nobody not us.
Well, David will be there in 30 seconds.
Okay.
Yeah.
That's your job.
So it is fine. I'll take a baked potato.
Wait.
Are
you vegetarian?
Sour cream and some fries.
Are you vegetarian?
Yeah.
I'm about to order some girls from some place. Do you want to just wait? We can DoorDash something. We can split. Okay, cool. What about you? Yes.
That's chicken noodle.
They don't have spicy chicken nuggets. They do it. Oh, it's crispy chicken nuggets.
Hey, Bob, you guys? Oh, no, got some background interference.
We're doing it. Like, I feel like so the answer to that is no. Yes. I mean, we can already hear you on the.
No, just chicken nuggets.
That's it. Great. Can I ask for you about something?
Yeah.
No, I'm not gonna do it. You're not getting Wendy's?
I'm not gonna get one of these, no.
Okay, that's fine. David, you said you're not getting anything. Okay, cool. Matt, Wendy's.
What's that?
Wendy's.
I'm just starting like a double combo with a sweet tea.
Yeah. What's this? Zip test.
Whatever you
A little bigger.
If they ask if you want regular or large, just say regular.
Regular for what?
They might ask what size, just say like regular size.
For the tea or for the
combo. For anything. Yeah. They'll say that for any combo. Cool. Just assume regular. But people will say it if they want to keep those.
I mean, not necessarily, but
I mean, people that are filling that come out, I think.
maybe, yeah.
Because can't believe they doubled that Taco Bell order price.
They did what?
Yeah, can I have my other half of my Taco Bell order actually? Can that be my lunch order? Yeah, right. Anything more to you? No, it is. Look at extra water, like really big. Doesn't matter. Just to keep you guys in the loop, the plan for the pneumatics is to just like bump the elbows. So have them like sticking together basically. The tubes will go up and out, so just don't put anything on the pneumatics. That's exactly what we were planning 30 minutes before you showed up, so. It might be different if David comes in, ask him about it, but I thought that was the plan.
No, I cannot run like that.
I know, right.
So where's that going? To here? You gotta route that somewhere else.
And you gotta measure this thing out.
I'm gonna go
talked about this. We're going to go underneath and then go above.
Okay.
So I'm going to overshoot it and then.
Okay, you're just trying to
You guys have a plan, okay?
Honestly, like.
It doesn't hurt to coil a little extra.
Yeah, we're just trimming up a little bit.
Yeah.
Yes. Alright, where's the Sharpie?
Yeah, that's about it. A lot of Sharpies too.
And then I landed the robot, and it went for all the things you let the robot go. Who knows?
I need more caffeine.
Sam, I'm about to go shove some Dr. Pepper.
I put some in my mug here.
One more cup for me, Colin?
Thank you. Have my
Yeah. We're good. Here, hold on. Just let me.
How many hands can you put in the robot?
Alright, so you know what?
Wire cutter doesn't actually go all the way back to the back of the jar. Right. These four?
Yeah. Mark these and go ahead.
I can fill them.
I think we say.
I won't go through this one. No promises.
I'm running an awesome
Guessing it would be very difficult to
Do what? Why do you need to move a wheel?
it might be nice to have the Omni on the other side as a battery.
That's what?
The battery's right here and the Omni, so yeah, it's not very centered. Right, Omni's don't really work that well.
The Omni should be on the side further away from the center of mass.
Yeah, it doesn't matter.
No,
it's gonna rotate about the center of mass. Yeah. We can switch it easy enough later if we have performance issues.
Like, not going back to plywood?
Issues, so you have to. You always did 1 by 6.
I just realized it's supposed to be 3/4 inch plywood, so we're gonna have to get 2 pieces of plywood from the wall.
It's just like, is this half? That's less than half, isn't it?
This is half inch. This is quarter.
That's not quarter, that's thicker than quarter. That's probably 3/8 or something. Alright. Yeah, slap 2 that's good.
It was nice, and then it just kept getting colder.
Pretty close to
See that car has the holes put in place.
it. Got holes. It means it-
Yeah, we got the holes that shit is
As soon as you possibly can, we need to get this back on the tape or on the ground so we can figure out where we're gonna put the home.
Yeah, we can work on the ground.
Well,
Or the
no,
table.
just go ahead and get that wired out.
Is there a different one with longer or are they all
Yeah, that's what we're just gonna put it there. Yeah, what's up? What do you want to order? Oh, we're gonna get it.
It's all Yes, yeah, I owe you $3.
And we have a whole other half a sheet here. Yeah.
Yeah, I just ordered the Coca-Cola. So
Yeah,
I still need
And I owe you
See, the Coke here is so good.
I know.
Mexican Coca-Cola.
It's so good. Actually, can we go ahead and move this?
It's all natural.
Go ahead and move this to a table.
Yep.
Watch out.
Ah, it's all natural except the cocaine.
Except the Coke.
I brought my bicycle
Street
needed.
here, okay?
Cocaine is natural depending on who you ask.
We're child-friendly.
Oh, it's definitely natural. Now, whether you should consume it or not.
Like I said, the stream should know too. Cocaine is natural depending
Wait,
on who you ask.
do we have a mic going right now? We should not be talking about it.
Oh, no, the mic is
We're alive, but is there a mic?
Is there a mic?
Yeah, we don't care about the live. We don't care if they can see.
Always a mic. We're being recorded always.
Guys, it's not like we're snorting it in front of everything.
Just behind me.
Let's not put that last part.
Oh no, they moved the mic.
Closer to us? That was a dumb idea. That's what we just did.
Alright, what can I do? If you can, slot out.
Hey, how you doing? Pile of just not mean anything we just said.
We need this like slotted out to here. Like, don't cut this. Just like,
Just don't cut the bottom surface, but cut the top surface.
yeah, we need like this material. This.
Yeah, you're good. Go for it. Both of them?
Yes.
Alright, I'm gonna
Get rid of this piece of crap.
pull the thing out.
Now that I brought my actual.
What do you do? Listen, I need to be like under it, so I'm not gonna hinder you like over.
No, I do not. Yeah. If this place has one thing, it is definitely not high quality tools.
Some of them are okay. The DeWalt stuff I like.
What's wrong, Ashutosh? I need water. Just good side. Here, let's run it.
That's what I'm doing.
That's what's gonna happen.
I have it now, don't worry. See how I did that one? Same way. But it'll be much more taut once I put the, stuff. This size.
Yeah, we got to zip ties.
Yeah, I will. Don't worry.
You know,
I'm literally just waiting on you guys because I need to get under the zip tie shit.
Oh, where's the next one?
I need to get under here to zip tie everything, so I'll do it on you guys first.
We're good now. We can keep looking up. Alright.
Don't worry about it.
Fire in the hole.
Fire in the hole. What hole?
Well, after I talked to Bill yesterday.
Fire in the hole. That's the part Max you just did, so yeah, that's what that means.
So I should have them do that before we put it on there.
True, although some of them you might have to refirmware, but we're just gonna pretend like you didn't hear that.
We know we
fire in the hole.
We might, I don't know.
Hey, I need to go back on the table because I need to get my hands under it.
Oh yeah, like I said, you can work, you can flip it over, do what you need to do. I will work.
You're the most important right now.
Well, that is like what I'm doing right now. I can do even if I'm living under a rock. So like. I don't like you. Like I don't like these cables, bro.
The silicone ones?
No, not that. The VR.
Why?
I really desperately hate the cable management on this.
Oh, the cable management on that thing is atrocious.
Wood screws?
Yeah. They're in the cabinet.
Yeah, I think they have some wood screws here.
Okay.
Yeah, there's a box. Okay.
Of our wonderful build space.
Actually, hold on. These are nails, aren't they?
That's the wonderful.
We have nails. We don't want to use nails. We definitely need screws. You can check for wood screws. I don't know where they are, if there are any. There probably are. Are there sheet metal screws?
Then I have to run one more set of these.
What's your plan for removing material?
I'm gonna try to take an angle here.
Oh, that did not work. Okay. Here, get an angle grinder.
We got a request from the stream room to move the robot closer to the camera. That's low priority.
Can you move the camera closer to the robot?
Yeah.
Because this bot is really good for us to work. Because everyone get around the robot. You know,
We want the robot near the tool. The robot is staying here.
basically, if you want to move the robot, you're going to have to move me with you.
Just remove that. Actually,
And I have good length.
do we need? I don't even think we need. I think we can just cut it here. Just cut it here on both sides, and we'll have it go in the two rows. I don't think just cut all the way.
David had it last. Just
On both or just one? Well, no, just like cut it off here, and we'll just use this filling. Or actually, yeah, cut off the ends too. We'll just leave that blank. All right, sounds like a plan.
It might be rougher than skateboard.
Do you want to remark so that we don't have a bend in it? No, it's
Yeah, I'd say
fine.
that
No,
works.
that's fine. Just cut it.
Testing on what we figured it out.
Hey, testing janky is fine. I've built a full flywheel thing out of plywood and then held two pieces of PVC as a feed. Yeah, as long as it's tested. If you're not working on something,
I'm trying to figure out
that way.
Yeah, that's fine. If you're doing something, stay here. If you're not, please.
There was.
Maybe you want to work on the climber?
I'm helping with the intake right now.
Yeah, I think that's what this is. David just said cut this.
David's making front bumpers so that you take more after your
What? Alright, your parts are cut.
Okay. There should be a lever on it if you was working on
Hey guys, you want to work on the climber? Yeah. Help him with the climber for now. I'll fuck up the intake.
test without buffers. Okay. So then, can you drill like 2 holes in each of these?
What
and
size?
then like 6 holes in here, and this is just so we can screw into that.
What size? Is this an acceptable drill bit?
Well, let me see.
Probably smaller.
Like this, yes. So we're gonna use like probably these screws. It's the same diameter, so we have like a pilot hole for that.
Yep.
Is it fine if we rip the front bumper on?
Zip tie.
And you're going through the metal and then into the wood.
Yeah, so we just want a through hole on the metal. And
Yeah.
then we'll pilot right over it. So like for the metal part that you're drilling, like this wood screws the slide. No, I can't.
Motor controller, there's one that's missing. One of the Spark Max that just device.
So you have 9 and 10?
I put
1, 2, 4. I got 4, 8, 9.
Do you have 10?
okay.
So we have all 10?
Okay, there's all 10.
Alright.
You said 1, 1, 1, 6?
2,
2, 2, 6.
Yes. Thank you.
Doesn't matter which side?
No.
We should not be using the TVs if we are.
Zip ties?
A lot that has to actually put stuff together.
What do you mean? That's how they're literally designed to go through the path.
I know. Why though?
What do you mean? The ties are pointing wrong. The tie's not gonna like just snap in the middle of the mat.
Zip ties are fine for competition robots.
Yeah.
They're not fine for government contracts.
Yeah, but we are. We're working on it. Yeah. You think we're not hired for the government?
I wouldn't hire at all. I'm doing this for free.
Ooh, I was doing this for pizza rolls. Yeah, right. Yeah, I mean, technically, you know, they were hired. So you could be hired in a forced volunteer drive all day.
What are you looking for? The broom. Here it is. Oh, this is the bucket.
Oh, you don't know what you said? No, it's probably playing in their range. No, I'm just looking at less number slide. Okay, yeah, 5, 6, 8, 9. Pre-programming. Oh, that's what I'm doing. I was about to say, I just need to know what to not program.
Thing is, you know those cameras that they use at like big football games and stuff? How it has the ropes on all corners and it moves around?
Yeah.
So my original idea was like, okay, hook here and here and then use a winch or a pulley system to where like if this is tilting the wrong way, you could like slide yourself the right way. But that goes too far outside the frame perimeter. So I wonder if you could do something similar right here and maybe adjust the weight.
Yeah,
Because like if you get someone over here and then like maybe you could adjust your weight so where it's all on one hook.
the counterpoint to that, assuming like all the robots are like 100 pounds or so.
Yeah.
This is like the least influential place to be to
Exactly.
change the level.
Yeah.
Yeah.
So I don't think that's even worth considering at that point.
Okay.
I think actually personally, I think that we would be fine simulating climbing on like a static beam because the levelness of this beam is going to depend entirely upon how you interact with the teams on your alliance.
Yeah.
You're going to have to say, okay, we're all hooked on, let's climb at the same time. Or have this person climb first, and that person climb next, and this person climb last.
Yeah, and if you're if you could climb in the middle and not tilt it much at all, you
Yeah.
wouldn't have to you wouldn't affect maybe the strategy as much because then other people could get over here.
And then the other thing is, if you get someone stuck over here, the thing goes like this. Now somebody can't reach it up here.
An interesting thought is that you don't have to lift much, like off the ground. That's it, less than an inch.
Oh, really? Did we do this, but can we possibly move this conversation like out the walkway and back there?
Then we're sorry, dude. But we're on stream here.
Flip the camera around.
Flip the camera. Can we flip the direction of the camera?
Yes. Sam, we need to flip the direction of the camera. Just got it.
Oh, that's why it's been cold.
Good job, Joe. Was.
I was like, my hands are getting cold. Why is that?
David, what did you say?
I'm wearing it. But oh well.
So yes, the rules for climb are just be completely supported by the hanger or by a robot on the hanger translated. So it's just off the ground. There's no bumper height you have to get past.
Okay.
Uh-huh.
So we don't have to lift that far.
Not far. However, you do have to think about if this is angled, how much different height does this change? Like if someone else has already climbed a little bit.
Yeah, it changes quite a bit.
Yeah, it does.
You have to climb a lot if you're gonna pull this all the way down and then lift up. So if you're not doing it at the exact same time.
I'm gonna go get the rules.
That's a good idea.
So really, if you have two people climbing on the sides, you have to do it at the same time, or be ready to climb. I guess you won't be lifting as much distance. You'll be pulling this down, and then you'll go back up.
Yeah, I see exactly.
I feel
what
like
you're
you
saying.
should still be able to do that, but also
Does that mean we should be able to control the travel of our hook, like how far it goes down? Because like if we're just sitting here climbing in the middle, you know, we only have to go up.
I think this is more analog than it is digital. Like not a piston, but a winch motor or something like that.
I agree. I agree.
We want to be able to like winch it.
Yeah, I think so. That lets us. That gives us so much more control.
So that design is not conducive to a winch, right?
What is this design?
So we have like two pieces right here, and there's a motor here, and it's connected with one gear. Well, it's connected to this piece, and it's connected with a gear to a shaft that has a rope going around. And the motor will spin counterclockwise and pick this piece up, which will mean this shaft spins clockwise and will roll the rope in
So
toward
this
the
folds
base.
that way and that
goes that way.
The rope will pull it up so it's upright.
So that gets us up there, but how's it gonna? We're just gonna run it in reverse to pull it down.
Right?
Yeah,
like that. Which is not conducive to a winch.
That is not linear motion.
No.
Does it have to be linear motion?
What do you mean?
I don't think there's any rule that it has to
Well, I
be
mean,
linear
you still have your extension outside your frame perimeter, 12 inches, if you want some form of sideways motion with it. And then it's just once we're in endgame in the spot, you can extend upwards, I believe, as much as you want.
Could we just put a hook on a string and toss it up there?
Yeah.
How are we getting it up there?
Like harpoon gun it?
Yeah, pretty much.
Or like
If you had
extended
a
tape
runner,
measure
you
type
could
thing.
Get a string,
They aren't-
and then you could just roll it up.
Yeah, they aren't gonna like that though, because the string, if it misses and you pull it out, that's more than 12 inches outside the frame perimeter.
That's not just they won't like it, that's a yellow or red.
Yeah, exactly.
That's really bad.
I don't know if you can fire like non-field element projectiles either, so you need
Well,
like...
it would be attached. But yeah.
But if that misses, that's way too much risk.
Yeah.
And it could damage...
You wouldn't even pass the inspection because they're like, that can go too far outside, you're done.
Yeah.
Could you have some sort of elevator system so you kept them contained, but could hook them up?
Maybe. What if we have, instead of the rope attached to this piece, we have it attached to the hook? And we have the hook like slotted in?
That's that's exactly what I was gonna say, is
So like
just something to take the hook up there.
Moves on this arm?
So like, no, the hook doesn't move. We get it up there and then we put the hook on. And then when we retract the arm,
the hook falls out.
Hook falls down. But then this piece is completely uncontrolled.
Are you retracting the arm by just reversing the direction of this?
I would assume so.
How are you gonna make sure the metal doesn't catch each other? Like once it's up, in position like straight up, how are you gonna get it to come back down?
Yeah.
I mean,
we wouldn't have the string anymore.
you really just need something to get the hook up there.
All right, so how can we get the hook up there? I think we want to like have something to place it on there rather than fling it.
Yeah, I agree.
How far is it? How tall? High off the ground?
I don't remember.
Hold on, I'm
It's
getting
about 5 feet off the ground, I think.
That's 3 feet above our robot. That's quite a bit.
Yeah.
the highest position would be 6 feet and 6.7.
The highest position is 6 feet.
6'7"
Yeah, 6'7".
is the corner of the coat hanger at its highest, and then in the middle at level, or anywhere at level.
The middle doesn't move
5
that
foot.
much.
5'3". The middle won't move much, but just at level, it's 5'3". And our robot's 2'4" at the top max because that's how it has to be
It'll
under
probably
the
be
trench.
like 2'3", 2'2".
Yeah. So we have to go at least 3 feet up to 4 feet.
So these were like, this was mounted at the front and it was like 1.5 feet long. I guess that would work.
Yeah.
Or 2 feet long. It would have to run the entire length
What
of
are
the
we?
robot at that
27 by 31, I believe, is our robot's.
Yeah.
We don't have to go up straight, you know. So if that thing's like on the very edge of the robot, right above the wheels, I mean, and your hook goes up, your hook goes from the corner. That's more distance to lift it, but also like we just have to get off the ground. Does that make sense? What I said?
Yeah.
Okay.
So like, yeah, we could do that.
No.
Okay.
No?
No,
I
it
see your
didn't make
marker.
sense.
All right, this is our robot from the top. So if we made this thing going like here, and then our hook came from right there, so like all that, it ended up folding up and out and whatever. But our hook ends up being right here, and our string is connected right here. Then it comes up, like we still have to lift basically what I'm saying is it doesn't matter where this is. We don't have to go straight up. We could go up at an angle.
We'd have to look
like a
at it more
Steamworks
if it
climb,
was there.
basically. Yeah.
But then won't that be swinging?
That
The
would
weight
probably
distribution.
Anything
But
with a
if
rope
If you're
is gonna
going
swing.
too fast, it'll swing, but
Like if you could anchor your string somehow
Yeah.
on the top and then like anchor it like the TV camera thing, but
Yeah.
reverse.
Mm-hmm.
Yeah.
Because you're gonna have to probably keep your weight pretty level.
I think if we have 2 of them, like if we have one on either side, then it'll swing. It might swing back and forth, but that's not gonna really affect the lateral motion.
Yeah.
So I think if we just had 2 of these, then that would be fine.
Mm-hmm. What are our goals with this? Are we trying to make it capable, or so that other people can climb around us, or
not on us. And what do you mean around us? Like if we climbed in the middle,
like are we trying? Yeah. Like are we trying to keep it level for other people, or are we just going up there and getting it ourselves?
I think it should be possible to either be on us on one side, another team on the other, and us both make it so we end up level, or us just in the middle and it's level. I think both of those are the goals. And also there's a time requirement we need to hit. But we don't need to lift any other teams.
So I know you said, like from this
Like that's gonna be
drawing,
the
being
most
able to adjust the tension on either of
that you
those
only need to
hooks
move
to
it
adjust
across
the thing, but if we put them on opposite corners, that's 27.5 inches. How do we calculate how much effect that would have on the coat hanger angle?
It's gonna have like a minimal effect because we're basically, if we do this, we're essentially going through the center of mass of
I see what you're
assembly.
saying, but would the 27.5 inches out, put them on either corner, would that have any effect?
How long is the thing?
The width or the height? What do you mean?
So like this way?
Yeah.
It's 10 feet.
It is?
Yeah. So being like a foot off of the center of mass
It's
on
not
either
gonna
side
do
is
much.
not gonna do almost anything.
Yeah, okay. I just wanted to make sure before we threw that out completely.
The center of the coat hanger is 2 feet below the actual coat hanger.
Yeah. Well, it's still in line with like the center.
Yeah.
Yeah.
So like that'll basically have, if it's even, it's gonna be 60 pounds down on either side roughly, and it's gonna cancel out and be static.
Yeah.
If it's not, then the difference is gonna be, oh, it's 1 foot, it's easy. Well, it's roughly 1 foot. Are we good with that assumption?
What assumption?
That since we're about 27 inches apart, or 31 inches apart, that we can say that it's like a foot or a foot and a half.
Yeah.
On each.
On either side, right?
Sure.
So the difference between torque on this thing is going to be like 1.5 times the difference from the center that the two ropes are at, or the 1.5 times the load on each of, the difference between the load. So like, if this side is bigger, it's going to be like 1.5 times that in this direction. But overall, if we keep it even, then it's not going to have hardly any effect.
Yeah.
If it's not even, that's a little bit of a more difficult problem to answer.
Yeah.
So like basically, if it's not even, then it's going to turn until the center of mass is in such a way that gravity is acting to put a moment on the system to balance our moment.
Okay.
It will also turn relatively slowly. I think this thing is pretty heavy. So it's going to take a lot to even just like start it going because it's got a pretty big moment of inertia.
That's true.
The robot or the hanger?
The hanger.
The hanger. But like once they got it going, it swung forever.
Yeah.
On that video.
It's low friction.
It's very low friction and it's not damped at all.
Yeah.
So the strategy, here's what I'm thinking. If you swing that coat hanger uncontrolled, you're not climbing that round.
It'll just be too hard.
That's it. Like it takes like 15 seconds to start.
We're gonna get so many things where like, oh my gosh, they're about to all climb successfully, and then one falls, and then they all fall.
One falls, and then it swings the coat hanger.
And then it knocks the other two.
Yeah.
And if you're hooked on like this, you could only slide the middle.
How much
piece
will
would
we
hold
slide?
on.
Yeah.
Yeah, that's
Because
true.
you could slide. I mean, even if you were the only one, or say you had your two other people fell off,
This is gonna
you
cause
would
some.
slide, but you would be caught in either direction.
You think lots of ropes broke? Lots of people are gonna fall off this.
At least in the North Carolina competition, there's going to be pure pandemonium.
Yeah.
I think.
It'll be great.
It'll be very entertaining to watch.
Mm-hmm.
The pit crew will be very sad, but.
Yeah, because like
The
if
hanger weighs like 93 pounds.
As a whole.
Less than the robot.
if you got like a 100-pound robot over here and the same one over here, and then that one falls off, that one's just gonna.
Aren't they gonna be more than a 100-pound robot?
You know, that's
I'd
interesting,
expect more like
actually.
140 because we have bumpers and battery. On
If
average.
the hanger, correct me if
the
I'm wrong, I
bumpers
might
are
just be
another
stupid.
14 pounds.
And then battery, another 15.
But if the hanger's like this, say it's like this,
Mm-hmm.
and we were already on there.
Yeah.
This rope is gonna slip a little bit, and it's not gonna add as much. It's not gonna hold as much weight as it was, right? It's gonna start relying on this hook.
Yeah. Definitely.
Is that
even though it's not much, that would be a counter.
is
right?
Well, why can't?
As long as it can support it from either one. I
Yeah.
don't think that's a problem.
I'm not worried about the rope. We can get like
That might
550 cord.
That might be advantageous. We have 550 cord. We haven't bought it.
Okay, because I was gonna say my team used 550 cord in Steamworks and like had no problem with it, except when there was like a sharp edge on that and it broke.
Yeah.
So
Yeah, the problem with Steamworks was just fraying and like sharp edges and
yeah,
pressure points always one spot.
Yeah. Steamworks is kind of different because you were climbing the rope.
yeah. Well, essentially, if you do a rope here, you're climbing the rope.
Yeah, you are climbing the rope.
You're just not trying to catch the rope.
But you're trying to climb the rope control.
Yeah, exactly.
Yeah.
And not far.
And like a winch is easy to make, but
Yeah, so that would be a winch actually, and not just like a shaft.
yeah.
Wait, so we only have.
What?
And with one of those half-inch diameter
Yeah.
hex
Where
shafts
is that rope?
and wrapping around.
Where would that roll be?
That-
Try just end game.
It'd be
As long as it
control
as long as
F
it
for
wraps
endgame.
the right way, you're fine because this is as it gets bigger, it makes it harder, right?
I think so.
Yeah.
Yeah, I don't see an issue with this system. Except getting the hook up there. We need to figure out how we're doing that.
Yeah. And my team ends up making a winch every year, it seems like.
How do they usually get the hook up there?
Should be in a section before fellows.
Drill a hole through a hex shaft, tie a knot.
I'm not sure.
And then it just wraps around.
Try hang, actually. Fill it for hang.
And what happens to the hex shaft? Or no, like, how are we getting the hook to the bar, I guess?
Oh, I don't know. Like, we'd have to figure something out that way.
So, like, this could work.
There we go.
We got to figure out a way to get the rope off this thing.
Yeah.
And still be able to, like, retract
Directly
this
translate.
control in a controlled manner.
4 or 5 seconds.
Yeah. The final assessment is not made until 5 seconds after.
So it needs to support itself and
match
stuff for
buzzer.
5 seconds.
I think the winch would do that because winches usually ratchet.
Yeah. Well, you can make it ratchet.
Definitely you want it to work.
Just literally what we did for Steamworks to make ours ratchet was we put a ratcheting wrench on it.
Swinging back
That's
and
what we
forth
did too,
for 5
actually.
seconds after it ended, and the robot was just like a pendulum, and then still scored.
We tried to, we actually like took a gearbox apart and like custom put a winch or like a ratcheting system in it, and then it didn't work. So we just threw a wrench. It like almost worked.
We like angle
we definitely
grinded.
stuck wrenches on ours to make it ratchet.
We're talking about like getting a socket wrench and just sticking it on there to ratchet it.
It works.
Yeah, it works really well actually.
That's what they're designed for. I mean,
Yeah.
They're designed for climbing robots?
they're designed for ratcheting under high torque.
That high torque? I guess so.
I don't know. I feel like I hit my wrenches pretty hard. I don't know the quantitative measure, but if we have 2 of them, then that would be like 60 pounds about.
Mhm.
And I've definitely ratcheted with 60 pounds before.
Yeah.
Alright, so can we turn this into a design and build it in like 5 hours? 4 hours?
If we want to detach the rope from the assembly, we got to figure out a way to do that.
The only thing
What
I'm
do you
also
mean by
concerned
that?
about.
Figure out where this is going on actual robot. Because we've got the ball mechanism to consider, but I think they're running that through the center. So if we kept it to the sides, we
To the
probably
sides
could
and
get-
or above. We might be able to go above it if it's thin enough, because
then
you've got the robot height, you've got maybe 1 ball's height, and then maybe we have room for us.
And just a thought, while we're extending this, oh wait, if we have a ratchet on it, then when it's extended, it's extended, right?
I think once it's extended, it needs
We're
to-
working on it. So this
I
is
think-
what we got right now. This might not be the best design, but it's the one that I came up with in about 10 minutes. So we got 2 pieces right here, and there's a motor here that's going to lift this piece up, and there's like a string or something attached just to get this one to straighten up. It's attached with like a winch, and we're thinking either we have like an independent string attached to the hook in here, or we somehow have like this string attached to the hook and be able to detach it. But I think having
Like
an
an
independent
independent
string
string.
is probably better.
Yeah, I agree.
Well, we don't even have to write the string through. We can literally have an independent string like just straight there.
Oh,
Yeah.
you're absolutely right.
Yeah. And that's a separate motor with a higher torque and ratcheting system?
Yeah.
Yeah.
And
then
do we have the gearbox for that? Like a motor and gearbox to do that?
we have like Versa 4-in-1s and 7-in-1s and stuff, right?
Yeah, we have enough gearboxes.
Yeah, we got like 4 or 5 and 7-1s. So yeah, we put the hook on there.
We gotta have a way to
retract this.
detach the hook. Oh wait, one thing before we talk about that. Are we going with 2 hooks over the center, or are we just trying to grab somewhere and hope we don't slide?
Well, what happens if we slide? Is that a big deal? Maybe.
If you slide, you're gonna slide all the way to the end.
You're gonna slide all the way to the end, and then
you'll slide
your
the end, or
robot's gonna come up
maybe.
like this.
So maybe we design the hook to be really grippy.
Okay.
Okay.
So like the steel pipe is not very grippy, right? It's pretty slippery.
Yeah. What if you had a tiny little pneumatic cylinder that just squeezed it?
Good.
That seems like a lot of work though, because then you got to run tubing up there.
the tube. Yeah.
But if you had a pretty strong clamp, you wouldn't go anywhere.
Yeah.
No. Yeah. Or we could just have it be like really hard to, like really frictiony.
Yeah.
Right?
Could you have a motor like slowly like clamp down on something, like almost like how the vise works?
What if we put like tire tread on the hook?
We could try different things to see for slipperiness.
Yeah.
So is the plan that it's like, is this the top view of something or?
Yeah. Are we gonna try to do this, or are we just gonna do two on the edge? What do you guys think?
I think if you did two on the front, you could probably get away with it without it.
Yeah.
So we'll table this for now. So the idea is that we're gonna have two of them like that.
Oh, on either, there's two of the same thing on either side of the front?
Yeah.
Maybe there's supports across, maybe not.
Thinking praying mantis like?
Yeah, like.
Where it's got both, they go up, and then we've got this whole rope thing to send it out, and then
we
a
eat
different
the bar.
rope,
I like where you're going. We
and
eat
then
it.
we eat the bar.
We eat it.
We eat it.
Bite its head off. I said that on stream. Hi, Chad. Anyway.
Hey, you aren't mic'd.
I am mic'd, but and they're looking at us too. So like. So yeah, I think that would
Is
work.
this good that they're this far apart? 27.5 inches or so? Do we like that distance? Do we want less distance? Would we rather them be closer?
That's a good question.
Well, if we're worried about other robots, I don't think the distance matters because our frame perimeter is still our frame perimeter.
How big is this thing?
How thick is that metal wire? It's probably like a 2x4 out of metal. My guess is 2.
I'm just curious about where okay, for lift.
Where what?
Where's the stuff going?
Oh, yeah, we've been talking about that.
On the robot.
Where this is either the front or the back. And ignore this blue, I think.
Yeah, the blue was.
We're tabling that until we think it is.
I think that would interfere. If you had something like that, it would interfere with mechanisms for the control.
For the control pad?
Yeah.
I'll just put it on the other side.
Well, we were actually thinking about, me and David were talking about this. I want to run this by you guys. Sticking the control, like, let's say it's like there's a support here, sticking our control mechanism like right here.
But it has to raise.
This is designed to raise already.
Well,
So,
we
like,
can't
this is
we can't
attached
raise too far.
before
You're
the-
not allowed.
Right.
Well,
There's-
we have
really-
45 inches, and our robot's only what, 2'2"?
That's a good point.
But I think it's probably better to do a more precise, like a level thing with.
Yeah, I like the thought of like pistons or something, because for the control pad you need exactly a number of inches.
That's
Never gonna
true.
change. For this, we don't know that exactly.
Okay.
Also, less force required, right? We just need something accurate for control.
I would
panel.
also, if you're doing with what I'm thinking you're doing like a hook that goes off and then you pull it with a straight rope.
Yeah.
Why do you need a giant arm like that?
To get it hooked up there.
Can't you just do like a hook on like a tape measure that you extend and then latch it?
I think this will be a lot easier.
Like
to aim.
just do a carabiner like thing that's connected to a small vertical linear slide. It hooks on.
Like a rack and pinion sort of thing.
2018.
That's true.
What I'm just saying is you just do a linear slide, a hook.
That
like
was
a
power up, right?
Yeah, not a hook, like a carabiner thing that you latch on. It will detach from the lift, and then you just pull from a rope that's
I
connected.
like Joe's idea. Let's look at some climbers.
Yeah. Yeah.
Yeah, and they were short robots.
How do
Wait,
we do that?
who was that?
Google Rotoraptors.
Okay.
2018 impression.
But something like this might still be useful for control mechanism.
I really
2018.
Wait,
For the control panel?
Yeah. Well, here's the thing, right? If we needed an exact number of inches,
The problem with that even if you do it like that, the actual mechanism that's going to interact with the control panel is going to be at an angle.
well, we can have it so that it's straight up like this.
And
Because
then
this
it
will
does
rotate. We can have it rotate so that it's flush and straight. What do you think?
I'm just thinking that's more stages of complexity compared to just a piston that's raising.
How high does the piston have to go?
Well, that's what we discussed earlier, is the piston, depending on how it's turned, like, so if our piston's set to go up 5'3", because that's where the middle is, right? 5'3", something like that. Well, this goes down too far. Now our piston's sitting up here.
Well, what
we're talking about the wheel of fortune. Right?
Sorry, I didn't realize that.
Okay, it would you just need like a piston that goes up 2 or 3, like 3 inches, and it just has a flat thing on it that has like a wheel is connected to a motor. You raise it like the 3 inches, the wheel engages with the control panel,
The surface,
or the inside if you want to do it that way. It engages and then they rotate, and it rotates, and then you just lower it.
Okay.
And that's just,
Maybe I should hear.
it's just moving a
I'll
flat
go into
thing up
YouTube.
instead of multi-stage.
I couldn't find 3737 on YouTube for 2018.
You can or can't?
I can't. But if we just look up a match that they played in during that season.
I wanted the chair. What? I thought I was getting the chair. No, I'm stealing one. It's okay.
That's a good idea.
It would have been in qual.
That's for weighing. We have 550 cord for this thing. This is stronger, but 550 cord is sufficient, and it's a lot thinner. You know what I'm talking about?
Oh, it says watch all matches.
The 550 cord has a operating weight of 180 pounds about.
But if we are 145 and we're max.
Okay, yeah, and then we can just fast forward to the end.
And we're swinging.
They are red.
Well, I mean, if we're doing the double hooks, that's.
Oh yeah, you're right. You're absolutely right.
Does anybody else have problems with the Wi-Fi in here?
It's because it's a cement building.
Yeah.
It's like the building's made out of concrete. It inhibits transmission a little bit.
I get good cell service, but I just don't get internet.
Oh, never mind. I don't know how that stuff works anyway. I should know.
I don't either, so.
This is a video in the climb, but you can't see anything.
Oh, okay. Yeah, that's really far away.
Oh my god, that's a massacre.
Yeah. And ironically, we're watching the red team for pointers.
Okay, it looks like they have a triangle thing.
And it just goes straight up.
What is that?
The password is So Norway knows. No one came over here and said we're having problems with Wi-Fi. I don't think anyone.
We're just YouTubing for inspiration.
Yeah, no, we're fine.
Yeah.
See, they have some kind of. They have like a hook that's coming in.
And it just goes straight up.
So basically a carabiner.
It looks like a triangle. Because see, you can kind of.
So is that like the tape measure thing y'all were talking about?
Yeah.
So
If you back it up, see, you can see it out here when they're moving. When they hook.
is it basically like the bar goes up like this, and then they're locked in?
Okay.
I don't know that.
We would need to find like a 2-inch diameter carabiner though.
Yeah, or make one.
I think we're fine with the hook.
I think they made theirs too because it's white. It's like, see,
I don't know how they got that to stand straight up like that. Or they just like do flat stock?
don't want to be any match. See, it's like you see the triangle?
Oh, they have their hook reversed. That's why it's working the way it does. Because I don't think that's really gonna be critical, but we can do a reverse hook. That would allow us to swing forward more.
If the battery in our center of the mass is at the back,
Then we want to
the reverse hook.
Yeah.
I think it's at the front, which is kind of weird. But
We'll just need to figure out whatever it is.
yeah, that's not particularly critical. But yeah, we need to figure out our hook delivery system to the hanger.
Mm-hmm.
You guys want to work on that? I'm gonna take a small break. If that's okay. Then you guys can.
Everyone, stay inside the building during the shots fireworks.
What did he say?
Shots fired.
Oh, that's a meme, right?
I've been texting.
Inside our building? Did somebody like fire the air riveter and it just made a weird
Private,
noise?
non-university residents. So like Circle Greens or something. Alex, just down there. This is the message that you're getting to. Yeah. Thank you.
Oh, I don't care about
So recap me on what the design actually is, as far as we have.
We have this thing that goes up.
The thing that looks like a stapler.
On an independent string. Honestly, we could use like.
Where are they doing? Wait.
I like this one.
This one?
Can we roll it back? We need to replay.
I need to move.
Okay.
Is this a hook?
I'm ready.
Yeah. Okay, well, went to
All the way back.
Yeah,
That's a short thing.
Oh, it's just the video of the climb.
Yeah, I got you a medium.
Alright.
You didn't say what size.
my bad.
That one?
We can't see how it hooks on.
1323?
Yeah, Mad Town.
We don't have an elevator.
The medium.
How did they?
Points right there.
Yeah, but how did they hook on?
I'm not really sure.
I guess we need to let him in. Watch out.
Trying to get more better views of just the hook part, but everyone's more excited about the lifting other people part.
Yeah. I assume we aren't trying to do that.
I mean, that'd be nice if we could do that, but that's outside of our.
It's cold outside.
Yes, it is.
Yeah. We wanted the 10-foot one for field sim, but like I can't fit that in my car, so I don't know how we would get it here.
There's this piece, solid piece, and then that's the piece that moves. So what you do is, I guess this video.
Oh, like a car door.
Oh. Yeah, that that could work.
Yeah.
This is the exact cab model that Road Rappers had, and we made like we had like a CNC machine that has that, where you don't have to make it like that precise.
To tell you the truth, I'm not really concerned about falling off. So I don't think we're gonna rock that much.
Yeah. Also, we don't have to be terribly concerned with that.
How are we even gonna test this?
Yeah.
We have a 5-foot steel bar, and we're gonna make an A-frame out of those 2x4s, and
Where it's gonna be static.
yeah, it's gonna be static.
It's really hard to
Because,
find videos.
like I was saying earlier, whether or not the hangar is level is more a function of team interaction than anything else.
Yeah.
Yeah, and that makes a lot of sense.
Whether or not the hangar is level is almost entirely a function of team interaction. So I'm not sure, since we're not competing, obviously you would want to design for this if you're an FRC team. But
I mean, I
don't know if we need to.
I think designing it such that we can do either here or here sufficiently does make it work for us. Because that's either 2 robots do that, or for the only one who climbs or can climb, we do the middle. And then that's either 40 points, or if you do it correctly on the sides, that's 65.
Okay.
Yeah, that makes sense.
Because having a middle climber that can get around
Getting around that would be great. Would one hook on one side of it also suffice? I feel like that would.
I feel like as a safety, we have to make it do that.
Say again?
Like as a safety precaution, so our robot doesn't fall, we'd have to make it so one hook could hold the robot.
Because then,
And then that should be sufficient with the rope.
and then when you tilt, if you have a hook on both sides, you would slide a little bit, but you would slide and you would stay on while you're swinging. But if you had one hook, you go and it swung that way, you go to the
You're
end,
absolutely right.
and you'd end up at the end and probably throw yourself off.
It'd probably break your entire robot.
Yeah.
Easily. Let's go.
Because I mean, basically, once this starts moving, the robot's just a big pendulum on the end that can be
It's only
kicked
gonna
off.
go 14 degrees though.
Yeah.
Our big
That's
problem
still-
right now is how do we get the hook off of the boat? Off of here.
Okay, so if we are using this, it gets up there, and then you want to like toggle this to be loose from this mechanism. What about if you just did like a?
We have like a door actuator.
Could you do something such that when it hits the bar and knocks it off?
I don't know.
Like,
or we could have it
I
hook
don't
on
know.
and then like drive backwards and there's a hole.
Yeah. You just gotta make sure
Then
it doesn't
could
fall
out
off
of the
during
hole
the game.
before.
Yeah.
What if we get like one of those door actuators, you know? Like it's got like a little thing in it and it goes.
Yeah, I know exactly what you're saying.
An electric solenoid?
Yeah. Yeah, exactly that.
You could use a pneumatic solenoid.
We could
You'd
use
have to-
pneumatics.
You'd have to run tubing all the way up there.
That would be harder. Yeah, wires are easier. However, no wires would be even better if it was only mechanical.
Yeah.
Right, because nothing else here needs wires, just the ropes, which are force wires.
But couldn't you run it through the middle of all that material?
Say again?
Couldn't you run that through the wiring through the middle
same
of
way
this?
we have other stuff.
So theoretically,
You guys want to workshop this over lunch? Food's here, and I don't want to get cold.
Okay.
Okay. Well, thank you for letting us know.
Sure.
Okay.
That
Should
was
we
a
bring
lot
this
faster
for
than
this?
last time.
Yeah. Yeah. Why not?
Should we bring this with us?
Yes. So it's up to you guys.
Should we bring this?
bring the whiteboard,
Bring the
yeah.
food here? No, we can't.
No,
do it.
can't
We can't. Bring.
They're gonna watch the strategy
Ah.
video. You guys can continue to workshop this over lunch.
Cool.
We can talk about it.
Yeah. And then you guys can recap for the video.
that's okay. In the shot, that's okay.
Brushless and brushed motors?
Everything's on camera.
I don't care about that.
Or you are large, but it's all the way over there.
Correct. And one thing I might add there is. Hi, I'm Aditya.
I'm Kyle, and we're going to show you what we did as far as strategy is concerned. So we came up with some terms and kind of broke the game down into some sections to help us kind of reason through and decide on strategy. So we're going to walk you through that. So that's kind of what you're seeing here. This is a simplified view of the field. We've split the relevant parts from shooting's perspective of the field into different zones, and we've labeled those zones with numbers. So zone 1 is your starting sector. Zone 2 is the area of the field behind the shield generator and behind the trench. Zone 3 is in front of both of those things, and Zone 4 is your opponent's sector. Note we do not assign a meaningful zone to the shield generator itself, because you're going to have a heck of a time shooting from there, so it was not really within our purview. Now let's break down these kind of different categories we have here. So there's 4 main components of strategy this year. There is your shooting / passing / dumping, or the way that you're actually using the power cells themselves. There's what you're doing with the control panel and whether you can rotate and position it into a specific place. The end game, whether you climb, park, do nothing, or some ambitious people may even decide to try to lift others, but that was outside of our analysis. And with the trench, you need to decide whether you're going to go under it, which is option A, under it, which is option A, and over it, which is option B.
One thing I'm going to sort of break down right now is sort of cycle times and sort of the way we came up with those, sort of using our prior sort of first knowledge and sort of some guesstimation. We came up with some sort of estimates for how long robots would take to go down some of those pathways, and then use those to be able to determine how long robots would, move across certain strategies, whether it's shoot 2, shoot 3A, which we will explain a little bit further. If you're really interested, you can go into our full analysis, which will be edited and broken down into the exact derivation of a lot of these.
In precise terms, what is dump 4A with control panel? So what that means is that what we're talking about is a robot that is low to the ground. It is below 2 foot 4 inches and capable of going underneath the trench, having taken balls from the intake, and then delivering those to the 1-point goal of the other side of the field. And then in addition, completing the control panel activities by rotating the control panel wheel, and ideally, if possible, climbing. That outlines our strategy and kind of the order of operations. And so it follows in that order. Dumping, manipulating the control panel, and then climbing.
Correct. And one thing I might add there is that we chose to sort of avoid shooting due to the complexities that involve a shooting sort of design based on sort of some sort of initial feedback from sort of our build team delegates to sort of see what would sort of work best for both us and given our short time span, and also what would work best for a broader first community who might be interested in sort of adopting a similar strategy.
As far as the end game, our priority is to climb, and obviously to do so in a balanced way. That's fully what we'd like to do, and we expect that will be what a lot of teams will be trying to do. It is very valuable.
And one other important point to note here is that we were considering sort of this is all just analysis for one team. It's sort of our view, and correct me if I'm wrong. At least my view, and Kyle, jump in here. That a combination of these teams is really what's required on a winning alliance in sort of playoff match play.
That's right, and being a team that really helps with the stages and the capacity and the control panel, I think means that you're a real aid to whatever team you're placed on, and you're going to help them get stuff done. Whereas it's very possible that as a shooting robot, you're not going to be able to help maybe make the difference between on a team that's less skilled, an alliance that's less skilled.
One thing I will add there is that sort of a dumping robot would get you a much significantly further along towards that ranking point during general match play than sort of most of their strategies, and was also part of our initial reasoning to be able to go down that direction.
Yep.
So those sort of it's our view that those sorts of bots may end up being the ones that are picking sort of in the early weeks.
That's right. If you can make the difference on your team and you can make your matches, half of your matches 4 ranking point matches or 3 ranking point matches instead of 1 less, that'll add up a lot. And we expect teams will be very successful who manage to pursue those ranking points.
Yeah. And one other thing that's very common in strategy is playing to your team's advantages. And here we're sacrificing shooting, very exciting part of the game to focus on things that would really add value to the team.
That's right.
In both in terms of the control panel, a niche part of the game, and also the end game, which
is incredibly valuable. If you look at the points assessment, you have to do quite a lot of shooting to justify not completing both of those other objectives.
So what we want to do here real quick is now run through some of these different strategies. You see, as we've already explained, sort of the breakdown of the field, 2A, 3A, 3B, 4A, 4B.
So if you remember from before, we numbered the zones of the field that are shootable from 1 to 4 from back to front. So Zone 1 is your own sector, and so it's not a place you can shoot from. That's why we start at Zone 2 here. Zone 3 is the part on your side, outside of your sector, but before you encounter the trench and the shield generator. Zone 3 is after both of those devices, but before your opponent's sector, and your opponent's sector is Zone 4. Now, the A and B scripts represent whether or not you're going underneath the trench. So A represents going under the trench, whereas B represents going around it.
Yep. And one thing, and then in addition to the pathways, there's the combination or the permutation across, the permutation across each of the different, shooting options, which is either shooting or dumping. And shooting, which we defined as, flywheel style shooting of some kind, or some way of getting the ball into the high goal. And dumping is sort of focused on the low goal. We didn't really consider any sort of mixed strategies there. We were sort of focusing on one or the other.
That's right. These are. This assessment of cycle time is pure. You can combine the cycle time analysis and the point analysis of multiple strategies together to create hybrid analyses. That is not something that we did.
Cool. You want to explain capacity value here, I think.
Yeah, so if you've been reading the rules, you might have noticed this kind of term called capacity that's been popping up. And capacity is really important for how you move between the different stages. Now, to activate stage 1, and that really means to complete it, you have to actually get 9 capacity, which is to say 9 balls from your team into your goal of any kind and in any of the different heights or locations. If you get 9 of those right and autonomous ends, and it always does, then you will enter stage 2. Now to complete stage 2, you need another 20 of those capacity, and you also need to do a control panel activity. Once you've done both of those, you can do another 20 balls and another control panel activity.
Right.
And so overall, you can't overflow capacity. If you have not completed the challenge of a stage, any excess capacity is lost. But the idea here is that capacity weights the fact that a ball scored in the 1-point goal is worth just as good as a ball in the 3-point goal when it comes to meeting those capacity requirements.
And one thing I will note there is, there is a little bit of a nuance to how those were calculated. Those were calculated not from those expected points point values, those average point values that we were talking about, but rather the individual probabilities, because we were indeed looking for the actual ball counts, the balls that were actually making it
So
in.
instead of, you look at the probability of you landing a 2-point shot, a 3-point shot, and a 1-point shot, you add all that together, you get the probability that you hit it at all.
Right.
You multiply that by 1, and you have yourself the expected value in capacity.
Right, and one other nuance that I do want to mention that we did consider was we did make sure that we noted the probability of missing shots, and we took
That's
that
right.
into account.
Probability of getting 0 points is kind of how we represented the idea of a miss, and so all the distinct outcomes here are covered. We'll talk control panel and endgame really briefly, and then we'll move on to our kind of final analysis. So what we did is, cycle time here is a misnomer. This is simply the time associated with those activities. But to rotate the control panel 3 revolutions, we did our best to estimate what that would entail based on reviewing the footage of the field tours, as well as inspecting our Lazy Susan that we have here. And we also imagined that positioning it, since that requires less revolutions, would typically be much faster.
Yep.
We've attached the point values on the right-hand side. We have climbing and parking assessed similarly. We looked at how long we expect that to take from a neutral position. And so altogether, that gives us the ability to assess the value over time of doing different things. And that's crucial to our final analysis.
Yep, and one thing I will add, it should be obvious at this point, but all of these cycle times and times are evaluated in seconds.
That's right. So it's in points per second or balls per second in terms of capacity rate and point rate.
And so now what we're going to do is sort of move into our final analysis, which should be sort of determine and govern our final decision of
That's right.
of what we plan to do for the next 48 plus hours. And so Kyle, you want to introduce that?
Yeah, so what we did is we actually took all that information, we put all the different shooting strategies in a table. To the right, we inspected kind of the different values of the different activities, and we noticed that capacity rate seemed like it was something that was going to be pretty hard to nail, and you'd need a pretty good alliance to get all of those objectives met.
Absolutely.
And so we, looking at that, we decided to kind of prioritize that cap rate column, and that's how we ended up with the strategy we chose, which was dump 4A, which is to say going to your opponent's zone and by way of the trench and then dumping. And that has the greatest effect as far as accumulating balls quickly. It's very, very rapid.
One thing that I will sort of jump in here and note is that we did consider the other strategies, and you'll note like sort of the gradient coloring that sort of denotes how valuable they are in terms of points and in terms of cap rate. And while a team that might not be there are two factors when we sort of walked into this analysis. There's this whole quantitative analysis, but there's also a feasibility analysis, and we had a few members from sort of the build team to help evaluate that in sort of an abstract sense. And so given our time constraints, we're looking at trying to focus on not shooting, even though there might be a greater effect in terms of either point rate or cap rate. There's a trade-off.
Yeah, exactly.
There.
And we also assessed the fact that doing that, choosing to dump instead of to shoot, would let us interact with more of the game elements in more interesting ways. And we hope you'll appreciate the diversity that gives in our robot.
Yep. And so one last thing that we did end up doing is sort of calculate, the total cycles that might, a robot might end up being able to perform, given those, those initial parameters, both total cycles, ball scored, and point bonuses, which you can note on sort of the last 3 columns.
So we're gonna start walking through some of the analysis in page 1. So unfortunately, the spreadsheet we have here doesn't necessarily have all the information that we broke down from times. It has the finalized numbers. We have those numbers recorded, in images and other places. What I can do is actually walk you through on the whiteboard potentially how we kind of estimated this piecewise and what components we used to estimate this.
And maybe one thing you could also do there is sort of show what a cycle might look like for this robot.
And now I'm going to proceed to kind of walk through how you start to estimate some of these, aggregate cycle times and things. So if you want to estimate, for instance, let's jump straight towards the one of interest, the one we actually chose, going to zone 4 and dumping in the goal. That journey has a number of steps. The first step is to load all of your 5 balls. Then you need to traverse 2-4 specifically. Then you need to dump and then you need to go home. So we estimated each of these parts individually and averaged the estimates that we managed to get from our panel. And that's what we used to create kind of the best effort aggregate estimations that we used. And we estimated different segments along the way and estimated both paths, both through and around the trench. And so by adding all of that information together and using, like I said, our estimations, we're able to come up with a number to assign to the time that it would take to do this. Because that's the time estimate, is the sum of all of these components. On the point value side of things, that required us to estimate how likely we thought each of these outcomes was going to be. Now for dump, that's very simple. We estimated that if once you've spent the time to line up correctly, you're not likely to miss any balls. So that's made that part of the analysis very simple. For that specific
the goal is pretty big, and so we're hoping that given the goal is pretty large, we're thinking that hopefully we're not going to miss anything there.
Exactly, and so dump is pretty reliable there, but we did assess the reliability of other strategies. That's part of what actually helps it out. Dump being very, very reliable, contributes to its cap rate, not just its speed.
And again, we are looking here at the average team. There might be, again, teams that are, much more, have lots of experience with shooters and can up that, probability estimate. And we might be able to open source this, spreadsheet, and you guys would be able to play with those probabilities based on your team.
And so the main way to think of it is that expected value of time and the expected value for the points is a function of your own skill. And so that will vary for you, in pure terms.
And we're being, we're a newer R3D team, and so we want to be, pretty conservative with the way we're estimating.
Exactly, and I think these estimates will be meaningful to the average team because they're fairly conservative but realistic as well. They're not very pessimistic. That would be an inaccurate framing.
Absolutely. And one other thing that I think is important to note here is the no bag at this point. And so we expect this game the meta of this game to evolve. I mean, obviously this isn't a complete
and the robots to evolve.
And the robots absolutely to evolve. And so this strategy is sort of what we see as sort of an initial gameplay. But as robots evolve and gameplay evolves, who knows what we could see in week 4, week 5, or even week 3.
Exactly.
All right.
And that's it for the strategy session.
I really appreciate your time and excited to see what your feedback is on this design. We're going to be posting this around, and excited to hear sort of your feedback on what you think of our analysis and what your ideas are in conjunction to what we have.
All right. Thanks.
Thank you so much.
Here's a shot. That's okay.
Brushless and brushed motors?
Everything's on camera.
I don't care about
Or you are large, but it's all the way over there.
Correct. And one thing I might add there is... Hi, I'm Aditya.
I'm Kyle, and we're going to show you what we did as far as strategy is concerned. So we came up with some terms and kind of broke the game down into some sections to help us kind of reason through and decide on strategy. So we're going to walk you through that. So that's kind of what you're seeing here. This is a simplified view of the field. We've split the relevant parts from shooting's perspective of the field into different zones, and we've labeled those zones with numbers. So zone 1 is your starting sector. Zone 2 is the area of the field behind the shield generator and behind the trench. Zone 3 is in front of both of those things, and Zone 4 is your opponent's sector. Note we do not assign a meaningful zone to the shield generator itself because you're going to have a heck of a time shooting from there, so it was not really within our purview. Now let's break down these kind of different categories we have here. So there's 4 main components of strategy this year. There is your shooting / passing / dumping, or the way that you're actually using the power cells themselves. There's what you're doing with the control panel and whether you can rotate and position it into a specific place. The end game, whether you climb, park, do nothing, or some ambitious people may even decide to try to lift others, but that was outside of our analysis. And with the trench, you need to decide whether you're going to go under it, which is option A, under it, which is option A, and over it, which is option B.
One thing I'm going to sort of break down right now is sort of cycle times and sort of the way we came up with those, sort of using our prior sort of first knowledge and sort of some guesstimation. We came up with some sort of estimates for how long robots would take to go down some of those pathways, and then use those to be able to determine how long robots would, move across certain strategies, whether it's shoot 2, shoot 3A, which we will explain a little bit further. If you're really interested, you can go into our full analysis, which will be edited and broken down into the exact derivation of a lot of these.
In precise terms, what is dump 4A with control panel? So what that means is that what we're talking about is a robot that is low to the ground. It is below 2 foot 4 inches and capable of going underneath the trench, having taken balls from the intake, and then delivering those to the 1-point goal of the other side of the field. And then in addition, completing the control panel activities by rotating the control panel wheel, and ideally, if possible, climbing. That outlines our strategy and kind of the order of operations. And so it goes in that, it follows in that order. Dumping, manipulating the control panel, and then climbing.
Correct. And one thing I might add there is that we chose to sort of avoid shooting due to the complexities that involve a shooting sort of design based on sort of some sort of initial feedback from sort of our build team delegates to sort of see what would sort of work best for both us and given our short time span, and also what would work best for a broader first community who might be interested in sort of adopting a similar strategy.
As far as the end game, our priority is to climb, and obviously to do so in a balanced way. That's fully what we'd like to do, and we expect that will be what a lot of teams will be trying to do. It is very valuable.
And one other important point to note here is that we were considering sort of, this is all just analysis for one team. It's sort of our view, and correct me if I'm wrong, at least my view, and Kyle jump in here, that a combination of these teams is really what's required on a winning alliance in sort of playoff match play.
That's right, and being a team that really helps with the stages and the capacity and the control panel, I think means that you're a real aid to whatever team you're placed on, and you're going to help them get stuff done. Whereas it's very possible that as a shooting robot, you're not going to be able to help maybe make the difference between on a team that's less skilled, an alliance that's less skilled.
One thing I will add there is that sort of a dumping robot would get you a much significantly further along towards that ranking point during match play, general match play, than sort of most of their strategies, and was also part of our initial reasoning to be able to go down that direction.
Yep.
So those sort of it's our view that those sorts of bots may end up being the ones that are picking sort of in the early weeks.
That's right. If you can make the difference on your team and you can make your matches, half of your matches 4 ranking point matches or 3 ranking point matches instead of 1 less, that'll add up a lot. And we expect teams will be very successful who manage to pursue those ranking points.
Yeah. And one other thing that's very common in strategy is playing to your team's advantages. And here we're sacrificing shooting, very exciting part of the game, to focus on things that would really add value to the team.
That's right.
In both in terms of the control panel, a niche part of the game, and also the end game, which
is incredibly valuable. If you look at the bonus assessment, you have to do quite a lot of shooting to justify not completing both of those other objectives.
So what we want to do here real quick is now run through some of these different strategies. You see, as we've already explained, sort of the breakdown of the field, 2A, 3A, 3B, 4A, 4B.
So if you remember from before, we numbered the zones of the field that are shootable from 1 to 4 from back to front. So Zone 1 is your own sector, and so it's not a place you can shoot from. That's why we start at Zone 2 here. Zone 3 is the part on your side, outside of your sector, but before you encounter the trench and the shield generator. Zone 3 is after both of those devices, but before your opponent's sector, and your opponent's sector is Zone 4. Now, the A and B scripts represent whether or not you're going underneath the trench. So A represents going under the trench, whereas B represents going around it.
Yep. And one thing, and then in addition to the pathways, there's the combination or the permutation across, the permutation across each of the different, shooting options, which is either shooting or dumping. And shooting, which we defined as, flywheel style shooting of some kind, or some way of getting the ball into the high goal. And dumping is sort of focused on the low goal. We didn't really consider any sort of mixed strategies there. We were sort of focusing on one or the other.
That's right. These are. This assessment of cycle time is pure. You can combine the cycle time analysis and the point analysis of multiple strategies together to create hybrid analyses. That is not something that we did.
Cool. You want to explain capacity value here, I think.
Yeah, so if you've been reading the rules, you might have noticed this kind of term called capacity that's been popping up. And capacity is really important for how you move between the different stages. Now, to activate stage 1, and that really means to complete it, you have to actually get 9 capacity, which is to say 9 balls from your team into your goal of any kind and in any of the different heights or locations. If you get 9 of those right and autonomous ends, and it always does, then you will enter stage 2. Now to complete stage 2, you need another 20 of those capacity, and you also need to do a control panel activity. Once you've done both of those, you can do another 20 balls and another control panel activity.
Right.
And so overall, you can't overflow capacity. If you have not completed the challenge of a stage, any excess capacity is lost. But the idea here is that capacity weights the fact that a ball scored in the 1-point goal is worth just as good as a ball in the 3-point goal when it comes to meeting those capacity requirements.
And one thing I will note there is, there is a little bit of a nuance to how those were calculated. Those were calculated not from those expected point values, those average point values that we were talking about, but rather the individual probabilities, because we were indeed looking for the actual ball counts, the balls that were actually making it.
So instead of, you look at the probability of you landing a 2-point shot, a 3-point shot, and a 1-point shot, you add all that together, you get the probability that you hit it at all. Right. You multiply that by 1, and you have yourself the expected value in capacity.
Right. And one other nuance that I do want to mention that we did consider was we did make sure that we noted the probability of missing shots, and we took
That's
that
right.
into
Probability of getting 0 points is kind of how we represented the idea of a miss, and so all the distinct outcomes here are covered. Okay. We'll talk control panel and endgame really briefly, and then we'll move on to our kind of final analysis. So what we did is, cycle time here is a misnomer. This is simply the time associated with those activities. But to rotate the control panel 3 revolutions, we did our best to estimate what that would entail based on reviewing the footage of the field tours, as well as inspecting our Lazy Susan that we have here. And we also imagined that positioning it, since that requires less revolutions, would typically be much faster. Yep. We've attached the point values on the right-hand side. We have climbing and parking assessed similarly. We've looked at how long we expect that to take from a neutral position. And so altogether, that gives us the ability to assess the value over time of doing different things. And that's crucial to our final analysis.
Yep, and one thing I will add, it should be obvious at this point, but all of these cycle times and times are evaluated in seconds.
That's right. So it's in points per second or balls per second in terms of capacity rate and point rate.
And so now what we're going to do is sort of move into our final analysis, which should be sort of determine and govern our final decision of
That's right.
Of what we plan to do for the next 48 plus hours. And so Kyle, you want to introduce that?
Yeah. So what we did is we actually took all that information. We put all the different shooting strategies in a table. To the right, we inspected kind of the different values of the different activities, and we noticed that capacity rate seemed like it was something that was going to be pretty hard to nail, and you'd need a pretty good alliance to get all of those objectives met.
Absolutely.
And so we, looking at that, we decided to kind of prioritize that cap rate column, and that's how we ended up with the strategy we chose, which was dump 4A, which is to say going to your opponent's zone and by way of the trench and then dumping. And that has the greatest effect as far as accumulating balls quickly. It's very, very rapid.
One thing that I will sort of jump in here and note is that we did consider the other strategies, and you'll note like sort of the gradient coloring that sort of denotes how valuable they are in terms of points and in terms of cap rate. And while a team that might not be there are 2 factors when we sort of walked into this analysis. There's this whole quantitative analysis, but there's also a feasibility analysis, and we had a few members from sort of the build team to help evaluate that in sort of an abstract sense. And so, given our time constraints, we're looking at trying to focus on not shooting, even though there might be a greater effect in terms of either point rate or cap rate. There's a trade-off.
Yeah, exactly.
There.
And we also assess the fact that doing that, choosing to dump instead of to shoot, would let us interact with more of the game elements in more interesting ways. And we hope you'll appreciate the diversity that gives in our robot.
Yep. And so one last thing that we did end up doing is sort of calculate, the total cycles that might, a robot might end up being able to perform, given those, those initial parameters, both total cycles, ball scored, and point bonuses, which you can note on sort of the last three columns.
So we're gonna start walking through some of the analysis in page 1. So unfortunately, the spreadsheet we have here doesn't necessarily have all the information that we broke down from times. It has the finalized numbers. We have those numbers recorded, in images and other places. What I can do is actually walk you through on the whiteboard potentially how we kind of estimated this piecewise and what components we used to estimate this.
And maybe one thing you could also do there is sort of show what a cycle might look like for this robot.
And now I'm going to proceed to kind of walk through how you start to estimate some of these, aggregate cycle times and things. So if you want to estimate, for instance, let's jump straight towards the one of interest, the one we actually chose. Going to zone 4 and dumping in the goal. That journey has a number of steps. The first step is to load all of your 5 balls. Then you need to traverse 2-4 specifically. Then you need to dump, and then you need to go home. So we estimated each of these parts individually and averaged the estimates that we managed to get from our panel. And that's what we used to create kind of the best effort aggregate estimations that we used. And we estimated different segments along the way and estimated both paths, both through and around the trench. And so by adding all of that information together and using, like I said, our estimations, we're able to come up with a number to assign to the time that it would take to do this. Because that's the time estimate, is the sum of all of these components. On the point value side of things, that required us to estimate how likely we thought each of these outcomes was going to be. Now for dump, that's very simple. We estimated that if once you've spent the time to line up correctly, you're not likely to miss any balls. So that's made that part of the analysis very simple. For that specific strategy.
The goal is pretty big, and so we're hoping that given the goal is pretty large, we're thinking that hopefully we're not going to miss anything there.
Exactly, and so dump is pretty reliable there, but we did assess the reliability of other strategies. That's part of what actually helps it out. Dump being very, very reliable, contributes to its cap rate, not just its speed.
And again, we are looking here at the average team. There might be, again, teams that are, much more, have lots of experience with shooters and can up that, probability estimate. And we might be able to open source this, spreadsheet, and you guys would be able to play with those probabilities based on your team.
Sure. And so the main way to think of it is that expected value of time and the expected value for the points is a function of your own skill. And so that will vary for you, in pure terms.
And we're being, we're a newer R3D team, and so we want to be, pretty conservative with the way we're estimating.
Exactly, and I think these estimates will be meaningful to the average team because they're fairly conservative but realistic as well. They're not very pessimistic. That would be an inaccurate framing.
Absolutely. And one other thing that I think is important to note here is the no bag at this point, and so we expect this game to the meta of this game to evolve. I mean, obviously this isn't a complete
and the
picture
robots to evolve.
And the robots absolutely to evolve. And so this strategy is sort of what we see as sort of an initial gameplay, but as robots evolve and gameplay evolves, who knows what we could see in week 4, week 5, or even week 3.
Exactly.
All right.
And that's it for the strategy session.
I really appreciate your time and excited to see what your feedback is on this design. We're going to be posting this around, and excited to hear sort of your feedback on what you think of our analysis and what your ideas are in conjunction to what we have.
All right. Thanks.
Thank you so much.
The shot. That's okay.
brushless and brushed motors?
Everything's on camera.
I don't care about
Or you are large, but it's all the way over there.
Correct. And one thing I might add there is. Hi, I'm Aditya.
I'm Kyle, and we're going to show you what we did as far as strategy is concerned. So we came up with some terms and kind of broke the game down into some sections to help us kind of reason through and decide on strategy. So we're going to walk you through that. So that's kind of what you're seeing here. This is a simplified view of the field. We've split the relevant parts from shooting's perspective of the field into different zones, and we've labeled those zones with numbers. So zone 1 is your starting sector. Zone 2 is the area of the field behind the shield generator and behind the trench. Zone 3 is in front of both of those things, and Zone 4 is your opponent's sector. Note we do not assign a meaningful zone to the shield generator itself, because you're going to have a heck of a time shooting from there, so it was not really within our purview. Now let's break down these kind of different categories we have here. So there's 4 main components of strategy this year. There is your shooting / passing / dumping, or the way that you're actually using the power cells themselves. There's what you're doing with the control panel, and whether you can rotate and position it into a specific place. The end game, whether you climb, park, do nothing, or some ambitious people may even decide to try to lift others, but that was outside of our analysis. And with the trench, you need to decide whether you're going to go under it, which is option A, under it, which is option A, and over it, which is option B.
One thing I'm going to sort of break down right now is sort of cycle times and sort of the way we came up with those, sort of using our prior sort of first knowledge and sort of some guesstimation. We came up with some sort of estimates for how long robots would take to go down some of those pathways, and then use those to be able to determine how long robots would, move across certain strategies, whether it's shoot 2, shoot 3A, which we will explain a little bit further. If you're really interested, you can go into our full analysis, which will be edited and broken down into the exact derivation of a lot of these.
In precise terms, what is dump 4A with control panel? So what that means is that what we're talking about is a robot that is low to the ground. It is below 2 foot 4 inches and capable of going underneath the trench, having taken balls from the intake, and then delivering those to the 1-point goal of the other side of the field. And then in addition, completing the control panel activities by rotating the control panel wheel, and ideally, if possible, climbing. That outlines our strategy and kind of the order of operations. And so it follows in that order. Dumping, manipulating the control panel, and then climbing.
Correct. And one thing I might add there is that we chose to sort of avoid shooting due to the complexities that involve a shooting sort of design based on sort of some sort of initial feedback from sort of our build team delegates to sort of see what would sort of work best for both us and given our short time span, and also what would work best for a broader first community who might be interested in sort of adopting a similar strategy.
As far as the end game, our priority is to climb, and obviously to do so in a balanced way. That's fully what we'd like to do, and we expect that will be what a lot of teams will be trying to do. It is very valuable.
And one other important point to note here is that we were considering sort of, this is all just analysis for one team. It's sort of our view, and correct me if I'm wrong, at least my view, and Kyle jump in here, that a combination of these teams is really what's required on a winning alliance in sort of playoff match play.
That's right, and being a team that really helps with the stages and the capacity and the control panel, I think means that you're a real aid to whatever team you're placed on, and you're going to help them get stuff done. Whereas it's very possible that as a shooting robot, you're not going to be able to help maybe make the difference between on a team that's less skilled, an alliance that's less skilled.
One thing I will add there is that sort of a dumping robot would get you a much significantly further along towards that ranking point during general match play than sort of most of their strategies, and was also part of our initial reasoning to be able to go down that direction.
Yep.
So those sort of it's our view you that those sorts of bots may end up being the ones that are picking sort of in the early weeks.
That's right. If you can make the difference on your team and you can make your matches, half of your matches 4 ranking point matches or 3 ranking point matches instead of 1 less, that'll add up a lot. And we expect teams will be very successful who manage to pursue those ranking points.
Yeah. And one other thing that's very common in strategy is playing to your team's advantages. And here we're sacrificing shooting, very exciting part of the game to focus on things that would really add value to the team.
That's right.
In terms of the control panel, a niche part of the game, and also the end game, which
is incredibly valuable. If you look at the bonus assessment, you have to do quite a lot of shooting to justify not completing both those other objectives.
So what we want to do here real quick is now run through some of these different strategies. You see, as we've already explained, sort of the breakdown of the field, 2A, 3A, 3B, 4A, 4B.
So if you remember from before, we numbered the zones of the field that are shootable from 1 to 4 from back to front. So Zone 1 is your own sector, and so it's not a place you can shoot from. That's why we started Zone 2 here. Zone 3 is the part on your side, outside of your sector, but before you encounter the trench and the shield jet.
Sorry to cut the YouTube video short, but you can find it on our channel at our website, fullmoonrobotics.org, and follow the link to our YouTube, and it'll include a link to the strategy spreadsheet we were talking about.
Overview on the mechanism.
We're coming up with a mechanism. I hope the very rudimentary idea right now.
So we're going to talk to the, I think this is some sort of strategy team, and ask them about what's going on.
And then a gear right here, and the gear connects to a shaft that has a string attached to it. And that string runs around and attaches up here. So when we activate this motor and spin it counterclockwise, it will spin this clockwise. So this piece will go counterclockwise up, and the string that's attached here will be drawn counterclockwise and down, and then it will stand upright. Okay. And what we're trying to figure out is once the hook is on the bar, this should raise it up to the right height. Once the hook is on there, we want to be able to disengage the hook from this system and just have it be like a hook attached to 550 cord that we can winch.
This is the climbing mechanism?
Yeah, this is the climbing mechanism. So we want to have another string attached to the hook that just goes straight to a separate motor. By the way, there are 2 of these. So there's one on one side, one on the other.
So 2 hooks?
2 hooks.
What's the choice to do 2 instead of 1? It helps balance?
It helps it balance, yeah. It takes some of the weight off the rope too.
Also, we were thinking about having a pass-through design, and if you try to, we're thinking about doing a pass-through design in the center of the robot for the actual field and power cells. And if you do that, it's a lot harder to actually do a central lifting mechanism because you have to offset it. And if you're already going to have to offset it, it's better to offset and do 2 instead of 1.
Yeah, that makes sense.
Yeah, and also that gives us the capability of climbing center instead of the sides, which is always nice,
Yes, climbing center. So is there going to be enough spacing on both sides of the robot to reach around the sort of center spacing of the bar?
We have
We've done some research on that, and it doesn't explicitly state the thickness of this, but this is going to be like a 30-inch.
I'm sure you can get the measurement off the field diagram.
Yeah.
All right.
Yeah. So that's our plan for now.
I'm going. This is just another idea. I'm just spitballing. Don't kill the messenger. Or I am not the messenger. I have that. But anyway, what if? So you're trying to do two things with one stone, right?
We were trying to integrate the control
Yeah.
in here.
So this is another idea that I have. We can do like a telescoping lift kind of thing with the rope. It's like we have, one block of PVC and another one inside of it and another one inside of that. And when you pull the string, it's like it goes kind of like that. You know what I'm talking about?
Yeah,
yeah. Because
I like that. I like that.
Yeah, whatever works.
Yeah.
But not only is it guided, we don't necessarily have the bearings, so it might be easier to do with PVC because
I
it
can build it
slides.
with the angled aluminum and some 3D printed parts, I think.
Yeah, or the reason I said PVC is because it just slides way faster.
But it's difficult to route string through.
PVC?
Yeah, because you can't really get pulleys in that mechanism.
You don't necessarily need pulleys if you do
there's a lot of friction going, like if you drill holes in the PVC and run cord to lift it.
Okay. Anyways,
This
I'm
is
not really
proof of
focusing on
concept
I'm just,
for now.
Yeah,
Yeah,
proof of
okay.
concept. I'm not really focusing on the how.
Yeah, okay.
So this is kind of the idea because then when you have the motor here, spinning it, you can have it not necessarily go the full distance up for the climb. You can just have it go the distance necessary for whatever the spinny thing is, and have that mechanism on there. Another benefit of this is whatever we use as a hook, or the only really constraint is you possibly might damage the idea, whatever concept you use to spin that when you go onto the hook. So we just have to make sure the hook is above the plane of that actual mechanism.
Yeah.
And the other thing is when you actually are, when I don't want to overextend by accident because then we don't know if we'll. Because I don't want to break that plane because this has the ability for the motor to keep going and extend up.
We're gonna add a limit switch or something. We have limit switches.
Yeah, or I was gonna say we can just have a hard stop with a piston and then we retract that piston to actually allow it to go the distance.
Encoder on the motor. Oh yeah, the motor encoder.
You can do software stops.
You can do software stop, yeah. Another thing is, when you do problem with these lifts is when you go to a certain distance and you want to hold it in that spot, we have to basically stall that motor. It's going to try to fall back down.
Yes.
So if we're going to spin that wheel, how are we going to keep it held at that position and keep it from falling back down?
Good point.
Well, if we have pneumatics on the robot, we can use that to actually put a brake on the cable. Whatever rope we're using. Yeah. Potentially.
Or
you guys keep talking.
What is the height?
What? I don't know.
Okay. The height that the what's an axe?
Yeah.
Oh. Okay, and the height of our robot, we want to still be able to
Just toss it
under the thing.
Well, your max robot height is 45 inches.
Okay, yeah, but what's the max robot height if you want to still be able to go underneath the?
I believe it's 3 foot 11.
3 foot 11, and that thing is 3 foot 6.
Wait, hold on.
What?
Don't we have to go under the 3 foot 6?
You're talking to go. Sorry, you're saying through the trench. Are you saying go under the trench?
Under,
okay, that's 2 foot 4. I thought you meant under the. I thought you meant under the switch when it was all the way down.
And the height of the thing is 3'6". Okay, so basically what we have to do is
You're gonna want to double check that because I can't.
We will when we actually build it.
I don't think
so. We got to gain a little bit more than a foot, foot and 2 inches, from the point of where we start at and to the final point.
Just for that, not for climb.
Not for climb. Yeah. For climb, we extend the telescope to its max, right?
Yeah.
So the maximum extension for the telescope should be designed so that it goes on that rung, and that's kind of
that it goes
actually a little bit above,
about
so we
4
can,
inches past the rung, at least.
Yeah, and then
is the rung in the middle.
And then for this, what I'm thinking is that we can have the entire mechanism kind of wave downwards, and then a piston shoots it up into the actual range. That way we don't have to worry about like bringing it to the, because if we make it pneumatic, it's gonna hold it in place.
Then we have to run a pneumatic line through this whole mechanism now.
I mean,
and that's gonna be
no. This mechanism can just be on the outermost ring of the telescoping tube. The outermost ring doesn't have to go all the way up. Because I mean, then you're just doing your pneumatic line to the actual post. You're not running the pneumatic line all the way up, or nor the mechanism. You see what I'm saying?
Hold up, so you're fixing the smallest piece and moving the largest piece?
What? No. So you have your largest piece, and then all the pieces underneath, right?
Yes.
So on this large outer piece, that one doesn't move, right?
Yes.
Right. Okay. So your mechanism that's going to spin this wheel. So this max height, we make it as high as our robot can possibly be and still be able to go under.
Like an inch shorter, but
an inch shorter, yeah. So this is at what, 2.3, and you have to go all the way to here, which is at 3.6. So we have a mechanism that lays on this plane right here. Right?
Okay, so you're talking about mounting a separate mechanism to the column.
Yeah, and that mechanism is angled down the whole time. But then when a piston actuates, it pushes it up, and so it's at this plane. Because all we gotta do is add a piston going up.
Might be kind of a pain to do with a piston, but I think we can do it. Yeah.
I mean, not really, because you can just have the piston go here. So that way when it's resting, the piston phase ends right there. When it's pulled up, the piston phase ends right here. It's right, I mean, it's just
I don't know if
we
can get that long a stroke length.
But we can get creative and use a 4-bar. I mean, it's not that difficult.
Okay.
Yeah. So there's several things that need to happen here. First of all, we got to prototype a way for this thing to actually go up and down. I get what you're saying with the pulleys. I think there's an easier way. I've seen an easier way. I'll try to find that video on YouTube.
Let's talk in just a minute about whether we want to do PVC or something else.
Yeah. I'll show you the video then.
Okay.
We don't necessarily need to design it with the motor and stuff right now, but we do need a proof of concept.
Yes. We're gonna do a telescoping.
Okay.
Like, have you seen a cascading lift?
All right. I'm gonna explain to you and David at the same time. David.
For both the climb and the color wheel.
The color wheel is going to be mounted on the side of the bottom section of climb.
So now we have one telescoping arm. We have two for the climb.
We have a pillar that houses the telescoping arm that has the color wheel mechanism mounted on its side.
Right.
So the color mechanism does not move with the climb mechanism.
Yes.
But it is
that on here.
Then how do you actually spin it?
Yeah,
it's going to be a piston actuated system.
Are there two hooks for the climb?
Okay, so you're saying the sensor is on the pillar?
I think we can just do it at one.
Well, I think
what happens when you slide?
You're gonna slide either way, whether you have two or one.
If you have two and you hook around the middle,
here's an interesting thought. If you have a robot,
so you can balance out.
If you have a robot that can only get up to the bar when it's level, and they hook on closer to the center, and you hook on further from the center, you can actually lift them while you lift yourself, even if they have no mechanism.
Oh, but then they still have to extend. If they can extend, then you're going to be able to climb. That's not really my point. But the point here is, if you hook up in the exact center, what if you're the second robot to climb, and that robot's already climbed? Then you're trying to climb on this phase, and the center's over here, and you wouldn't really be able to do it. Because then at that point, because you can't angle your robot.
I also think that climbing in the center is only a feasible strategy for 1/3 of robots.
Yeah, it wouldn't be really.
Well, you could not climb, but with two, you could not climb in the center, and you could go for over here.
I mean, with one, you can go over here too.
Yeah.
Yeah. I mean, I'd rather target one side, and then the reason I say only one is because it makes our life a lot easier dimensionally on our robot.
Worst case scenario, what's the height of the bottom corner of that thing if it's tipped all the way to one side?
Like 3 feet. I mean, that's what we'll make it to. The max it possibly can have to go.
So if it's tipped all the way to one side and we're hanging off that lower corner,
I think our robot will still be hitting the ground, right?
The lower corner is only like 3 feet or something off. Like
if that mechanism is like this, and we're hanging on this corner, what's this distance?
That's like 3 feet,
Well, I
6
mean,
inches.
once we pull all the way up, we're not going to be hanging on the corner.
Not if
Pull up.
if that's 3 feet.
If our robot's stored in 3 feet. Our robot's max is 2 foot 3 inches.
Wait, we're doing
Right?
2 foot. Oh,
in this direction,
In the length direction? Oh, you're saying
or
with the tilt?
in this direction if we do it on one corner, or what are our options?
I mean,
So you gotta keep it balanced. That's why we had 2, was to balance the robot.
but if you have 2 like this,
2 is
right,
a lot of extra
you're still-
mechanism weight and
Yeah.
motors and.
If you have 1, you're not going to necessarily flip that way if your base of that mechanism is strong enough. But if you're talking about flipping like horns, like if your entire go that way, that'll still happen with 2.
I want to know that if that thing tilts all the way to one side and we're all the way in that bottom corner, our robot can still be off the
I understand
ground.
what you're saying,
I
yeah.
want to know that that is the case.
What if we put something on the hook that prevents it from sliding?
That's going to be a pain.
We discussed doing something with like friction or being able to clamp to it.
Because that can get to a 14.5-degree angle.
I mean, if we do 2, all right, let's try with 1. If we need 2, we'll just mirror.
Can somebody get a manual and get me that distance, please?
Yeah.
Thank you.
Could you print that thing?
Here, somebody take that.
The problem we have with 1
Let me check on the Slack.
You're not really fixing anything with 2 other than it balancing left and
Yeah,
right.
well, it makes the robot slightly shorter. If you're not hanging off one corner.
Yeah, you're hanging
But-
like this rather than this. But the degree of rotation on that is 30 degrees. So if you do your hypotenuse of 27.5 and 30 degrees, your height that you're gaining is like less than 4 inches.
Yes, that sounds
Not
about
really
right.
that significant.
Yeah. But I
don't think it's significant enough to add a whole second bar. You know what I mean?
it is only if
Our
we're
robot's not-
within 4 inches of the ground.
But we aren't, because
I want to.
it's 3 foot 4.
Even if we're 90% sure of that,
Yeah,
I
you
want
can
to make sure.
you can make sure.
So that's
Well,
why.
If it's 3 feet, our max robot height is 2 foot 3 inches. So we would still have 8 inches.
Not necessarily if we're like if the mechanism, if the winch motor is a foot up here.
Why would the winch motor not be on the ground?
Well, because it's gonna have to be above the chassis. It'll probably be at least a foot off the ground.
The winch motor?
Yeah.
Yeah, okay. But it would still
10 inches maybe. So then you have 3 Pythagorean directions to the opposite corner of the robot. And once you add bumpers on, we're getting pretty large.
That's true. Yeah. You're close, but I think you're still under.
That's just why I want to check.
We should recheck.
Yeah.
I'm pretty sure. But yeah, what do you? I mean, I think this idea is more feasible than.
Yeah, I agree. All right. Can we find that PVC here? I'm gonna check that.
Anyone got a computer? You have a computer? Yeah. 1 foot. When it's. What is the max when it? Okay, yeah. Lowest position is. Oh, it's 3 foot 10 and. So it's almost 4 feet. We're good. In order to count as a climb, how high do we have to be off the ground?
Off the ground.
It doesn't
Literally.
say.
Yeah, we're just gotta be off the ground.
Not touching the ground.
Yes.
The max is 3 foot 10 and a quarter.
The minimum distance that we'll have is 3 foot 10 and a quarter.
We're good.
Well, that's from the bottom. That's not even from like the rung. That's from
The very,
clearance.
yeah. Like, we're fine. Well, we're okay. That's my computer.
Yeah.
And I could,
They're tested.
can you pull it up and then check the actual dimensions of the part?
we're going to be within 8 inches, but we should clear it just with a rough measurement. Yeah. If we put 10 1/4 will work if we do one each motor. All right, I gotta help David real quick.
Didn't over me. There's no bearings in there. Yeah, no, that's just going straight up. Yeah. You don't really need bearings. You have QC's $4.
For every single stage you add that's inside of cascading lift, your max height will be half because of the rope's tension that goes around it. So if it's at the same place, right, the inner stage will hit the top of that top stage, and like you won't actually gain. Even though the stage is the same height, your distance doesn't increase by double, it increases. Like the first stage gives you the full length, and then the second stage you add will give you the half of that full length, and the third stage you'll add will give you half of that full length. Watch 1678's video on cascading lifts. They explain that thoroughly.
No, hold on. There's a specific design that I'm looking for.
Also, we don't really have.
When you hook it,
Yeah.
is it gonna send the rest of it, like, are you going to tilt it when you're flying?
Are we gonna tilt it? I mean, inevitably it'll tilt.
See, that's what we were trying to do.
You don't want to do that?
Double.
So we can have two. We can do two cascading lifts, and then have a crossbar that connects the two.
Yeah.
You want to do that?
Couldn't you extend more than half, like having like the whole lower end of the stage, like where the pass-through is?
Because we didn't want to.
Yeah, you could.
It literally will not do anything. They're not connected. You can have up to 80%.
We didn't want to hook on and slide and swing ourselves off, like, by the motion of the, like, we didn't want to throw the robot off.
Yeah. That's telescoping. That's what I'm saying. We gotta do telescoping, not cascading.
Well, no,
this is a cascade.
You can rig these as cascading too.
So rig them as cascading, but use the telescoping concept of it?
Yeah.
Okay, that works. The only thing is it'll like be long, but it is what it is.
If you do this with angle though, angle aluminum, it'll be fairly compact.
Yeah, those are pretty quick to set up.
Angle aluminum.
No, just that style of doing.
Oh
it.
yeah.
Can you help me CAD parts do it in angle aluminum? And get those printed.
Are you sure you want to do angle aluminum? Because I have to have. You have to think that I have to have something that still mounts this thing. I can't really mount that to angle aluminum.
If we were using something like, what would
we can do the. All right. Well, what do you want to do it out of? Versa.
Yeah, I would say Versa.
All right. We can make that happen, I think.
It'll be heavy though.
Yeah.
I don't like that.
That's a lot of force that we don't want. Okay.
Is there anything that we could use that please?
Can we do the bottom out of Versa and the rest out of angle aluminum?
But
Yeah,
you need
fine.
the with this.
That works for you? Okay.
How are we doing the top and the bottom?
What'd you say?
The channel inside of it.
We're not. We're just gonna. Yeah. We're gonna have to 3D print something that goes around the edge of the angle aluminum.
Okay.
Yeah, it holds it in place. Because we only really have to latch the hook on. We don't have to use that to actually climb.
I'm asking. No.
This just has to hold enough weight for like a magnet and a hook.
I was more asking about the actual slide, the actual stage.
What about
like, is it just the aluminum thing is the stationary thing at the end?
We're gonna put a square tube of aluminum, and then from that'll be stationary. Each stage off of that will be an angle.
Programming's already testing their actual chassis, so we want to get that on the stream. Hey, you guys.
Okay, take this. Hey,
Do you want to take the computer with this?
okay. So Eli and Colin, how about you two get that cascading lift up and running, or telescope, whatever the heck it's called. Get it up and running dimensionally and get the parts to you. I will work on the mechanism that spins the thing. Sound good? Okay.
Awesome. I guess I'm getting mic'd up. Anna, it's going to Noah.
You want me to do it or you do it? Okay, cool.
Yeah, the only motor that should be running is this one.
Okay.
The side towards me, Omni.
I can move farther, Sam.
Yeah, let's get the robot a little bit more in. There's all of this and that. Okay, this should definitely be good.
Okay.
Okay,
We're ready when you are, I guess.
I'm walking right into the stream.
Yeah.
Okay.
Let me make sure there's no wires or strings in the way of the
Tuck
chain.
in your strings.
Yeah.
All right.
Yeah, we should be good to test whenever you are.
Okay, enabling. Robot is enabled.
Okay.
What's the
Yeah, that's moving. It's moving something, but something's disengaged.
Something's disengaged?
Hey, Todd.
Oh, that's fine. It's fine.
Oh,
if
never mind.
They said the shifters are going to be disengaged.
Okay, yeah, the shifters are wonky. Never mind. I forgot these are shifter gearboxes. Okay. Yeah, they're just disengaged.
Pop the next fuse in.
Okay, do you want me to just pop this one out?
Yeah, probably do that too.
Tell us what you're doing right now.
Okay, so right now we're testing one motor at a time. So we just tested motor number 8, which is this motor right here.
Okay.
And that motor ran. So we're
So we're
just
gonna
texting
do
the next one.
13, which is 9, which is opposite side.
Great.
Yeah.
Enabling.
Okay.
Side.
That's not going. It's not getting a signal. That's what the light isn't changing, so it's not getting a signal. What? It should be that motor.
For some reason, is it on the other stick?
I can try. Get your hand out.
No.
Get your hand out.
Oh, yeah. No.
Okay. So that one we'll come back to that one. Let's try another one.
Okay.
Oh, wait. That one's set to follow the other one.
Oh, okay.
So we need to have both of them in to test that.
Okay, then I'll just hold the motor in that case and see if it actually moves. Okay.
Okay. Ready?
Yep.
Enabling.
Okay. Yep, the motor's actually, I can feel movement inside the motor.
Well, yeah, but it's also on a gear.
Yeah. Sounds beautiful.
Yeah. Okay. Disabling. Let's put the fuses in and do the other side.
Okay, so
just put both in.
It's gonna be 12 and 3. Okay.
All right, enabling.
Oh. Yeah. Yeah, well,
Which are the two motor controllers for this side?
It's gonna be 6 right here and 5
right there. Okay.
Yeah. Is that what we have down in our code for? Yeah, that's right. It should be 5. Yeah.
Sorry, I don't want to run it.
I was about to say 5 and 8 are the masters, 6 and 9 are following.
Okay. There's nothing on the status lights of 6 and 9 to indicate that they're actually following.
Okay.
Yeah. You know what I could do? Can I get in there once real quick?
Sure.
Yeah. Do you want me to run it?
No, hang on.
Okay.
Yeah, go ahead and run it.
Okay, make sure your sleeve and hand is clear of the gears. Is good? Okay, running. Okay. This isn't running. Is this wired?
Yeah, it's wired into
compressor pressure switch. Where's the pressure switch? Pressure switch isn't wired.
Oh, yeah.
Give me a paper clip.
Do we have a paper clip?
Do we have a wire?
Yeah, I can grab some PWM.
Okay. So now we're testing to see if our compressor is running. And we need to connect our pressure switch.
Oh, no, that's not gonna work.
So we're gonna get some wire just to first check and see if the pressure switch will go. And then second, to wire up the pressure switch.
I got orange and yellow jumpers.
Okay, sweet. We need.
Oh, they're.
Yeah. Okay. Let's see what else we can find.
Yeah, I thought they were mail.
Can cables if we can't find anything else.
Female.
We're gonna do what's like the base and then 3 8.5 row stages.
Alright, sounds good. This is gonna make the gearbox and the wheel spinning that allows us to actually
I found some can wire.
Okay.
There was something over here I wanted to check. Also, there's more. Grab this somewhere. Something over here that I wanted. I don't remember. It's fine. We'll come back. Also, is this set to the correct setting? 24 volt. Is this a 24 volt? This is a 12 volt compressor. And this is set to 24 volt. Let's turn it off and get a screwdriver. And hope we didn't break the compressor.
See, that wasn't even something I thought about because this is the PCM for my shop and all of ours are 24 volt.
Yeah, this is a 12 volt compressor.
Yeah, I see that now after reading it.
How the heck do you get this out?
Okay. That's all.
Okay. Let's try that again. And look up the status light codes for the PCM as well.
Okay. Well, does the robot have to be enabled for it to just?
For that to run, yes.
Okay.
So I'm gonna enable it.
Okay.
No, has to reconnect. Okay. Enabling.
There we go. That sounded violent.
Shaking. How we're looking, guys? Oh lordy, it's shaking.
And enabling. Cool. Okay, so we need some wire to wire up the pressure switch. We probably shouldn't use this CAN cable.
Is it not working?
No, it works. It's just not wired right.
Yeah. We need wire to go from here to here. And so forth.
Okay.
Yeah.
Are you wanting me to do that, or?
I'm wanting somebody to find ideally black and red wire.
What are you guys working on right now?
Okay.
Other than that, everything's working so far.
Yeah.
Shockingly.
Do we have a sitting around Neo?
I could probably find one.
Okay, because I want to ensure that follow mode is working properly.
Yeah.
Since the status lights aren't changing, that makes me slightly concerned.
Do you guys have a Neo over here that you're
here's
not
one.
using? Oh, never mind. We found one.
Oh yeah, but I wired up one. Okay, I want to ensure that follow mode is working
I was going to say,
properly,
I
which
don't
means
come down here often.
Follow mode. This is supposed to mimic the activity of this. but since they're geared together, we can't tell, and the light isn't changing, which leads me to assume that maybe it don't work quite right. So.
What's wrong? I was about to say 2 of the motors are 5 and 8 are programmed as masters. 6 and 9 are just programmed to follow.
Something for wiring. What did you
wire? The limits or the pressure switch is not wired.
Yes, we know that, but this is also not hooked up to something, so it will never get up to pressure.
This is true.
Yes.
Okay.
So, kid, if you guys
but it's a normally closed pressure switch. Yeah. So whatever. At some point, it needs to be wired. We tested it by shorting out the this. So.
Okay. Yeah. I mean, if you don't want the compressor to run, then for right now, just like jump through that. That's what you need to do.
It's the other way around.
Leave it
but
open.
Yes.
Yeah, just leave it
so
open.
To test it, we
jump it.
Yeah.
Okay, yeah. Just
So.
leave it open for now, because right now I'm not worrying about pneumatics.
Okay.
So.
Make sure it's got enough space to slide.
Okay. I think there's a clip on the bottom, maybe? Is there?
No, there's.
Oh.
Here, do you have a?
Dude, I'm gonna pull it out because I got like tiny hands.
Yeah, sure.
This cable's.
Boom.
I've been told are very delicate. So
Yeah.
Try to.
Okay. Let's get this in. Now it's complaining that there's no encoder.
Boom, tiny baby hands for the win.
Yeah, okay. I'm going to have you hold this, because last time we did this thing...
It jumped on the table.
Yeah. So I'm going to have you hold that very strongly, securely with both hands. So I'm enabling?
Yep.
And I'm going to move that side.
It's moving.
But now the light is red, see? And it wasn't doing that before, I feel.
Yeah, it wasn't.
That's odd. Maybe it's just because we rebooted. Let's see what the other side does. Your hands clear of that?
Yep. Yeah, 9 is on now.
Okay. But it wasn't doing that before, right?
It was not.
Okay, I have no idea what happened.
Well, rebooting it made them work.
Okay. Well, now we know.
Okay.
Disabling. Robot is disabled. Let's put on the correct motor here. You want to get that out?
There you go.
Yep.
Is it working?
Yes. We think rebooting fixed it.
And then the holofax sensor is which one?
This is the one we're not using. No, this is the right one.
Yeah.
And then the holofax sensor.
Okay, I didn't see it. I'm blind.
Anyway, once you get that back in,
let's test it again with the motor.
Let's test it again, and then we'll program the radio.
Awesome.
It's not in all the way. It's complaining that the encoder is not there.
Oh.
Hopefully we didn't break it. It's complaining that the encoder is not there.
They're like misaligned.
It's complaining that the encoder is not there.
And it was doing that before.
Before, as in the first time I said it? Or?
No, as in, but before we changed motors, it was doing that.
Well, right now, the encoder might be damaged on this one. Yeah, well, it was doing it not before we changed motors, but while we were changing motors. Well, we got the disc done.
Tell the stream what's happening. No. They're mine.
Yeah, speak.
So we're working on field pieces, and this is the control panel disc. And thankfully, our programming tables behind us are the exact right height to just set it on top. And the same width too, 30 inches. So how convenient. I think that was first idea with that is that standard workbenches are pretty similar in size.
Yeah, we're gonna need to take one of your tables, but yeah.
Okay, now we need to cut a hole in the bottom of the table so that we can view up and see the colored vinyl that we're going to put this on this, right?
I mean, even the plans they give you for like doing this don't have see-through bottoms, so
I feel like
no.
seeing through the bottom is a pretty important part of this game. So
it is.
Or at least of our design.
But this is the mechanism, and then seeing through you can do that on a bench.
Yeah.
You know,
seeing won't make it difficult.
Okay.
Like you see in color.
Do we want to? Step one is try a reboot.
It's been, we started at 1:30.
Step two is to unplug and replug.
You have a question about the controller setup.
We have a question about the controller setup. It looks like it's happy now.
Gonna look like.
I'm going to enable the. Where I'm going to wait. till
Maybe
that-
got angry because we unplugged
what's
it.
our question about the controller setup? What's our controller setup going to look like? Okay, so right now we just have four Spark Maxes. We have 4 Spark Maxes running on the CAN bus. We have in total what we purchased. We purchased 6 CAN SRX or Spark Maxes, and we plan on using I believe we're currently planning on using 2 for the intake, 2 for the elevator, and 2 for whatever our outtake mechanism is, but none of that is finalized at this point. But that's how we plan on using the 10 controllers that we have. Yep.
Wish we had a room at our school for field pieces. I said it. Wish we had room at our school for field pieces. LOL. I love that.
Yeah, I did.
Did they mean motor controller or like controllers?
Oh, did you mean controller setup? Because currently we're using these 2 giant controllers, and I think the plan is to switch to a PS4 controller. We just didn't want to change the code right before we tested it. So
controller setup is maybe a little bit less critical for our idea.
yeah, it's not really important for us. We hadn't figured out where we're going to put the buttons. I don't know, just it doesn't matter that much. Okay. Whatever the driver is comfortable with is what a regular team should do.
Yeah. Okay.
Okay. So
it might have been unhappy because we unplugged the Hall effect sensor while it was plugged in.
I'm going to enable it, and we're going to try it again.
Okay.
Running.
And now it's doing everything like it should.
Okay, so let's flash the radio, and then get them to shove it in gear and take it outside.
Okay.
We can power it through the robot, except for the zip type Ethernet. Do we have another Ethernet cable? Hey, Matt.
Todd, do we have another Ethernet cable?
That's what we got. Okay, can you bring us some diagonal cutters then? For what? Cutting these diagonal or zip ties? David, no. No.
Yes?
Ugh.
You offered me a pen.
Oh, I barely touched the wire. Dang it. Whatever.
Also, this did come unplugged down there.
Nice.
And it's not turning back on. There it goes.
There.
Okay.
Well, let me get some tape for it.
So, hold on a sec. Are you set up for HDMI capture right now? Okay. How easy would that be?
Do you have electrical tape over here? Yes, you do.
Okay. If I bring my laptop
No,
over
I'm talking
here
to
while you
myself.
go get that, can we do programming a radio on stream? Okay. Cool.
You can keep wearing the lab.
Okay.
It's still black.
All right, thank you.
I could fit an 8-piece in my car. An 8-foot piece. If I have to. Okay.
Probably a little too small.
Yeah, I was about to say, you can get it pre-cut if you need to, or if we want to just get an 8-foot piece, I could get that if we need to. Okay. Here, where's my little uh-oh?
There's your little boo-boo.
Boom, little boo-boo solved. It's no longer a boo-boo, it's just a piece of tape.
Yeah.
Here, I'll get the robot. Except for the laser cutter in the way. Yeah, this is as close as we can get that way.
Okay. Can we get it like back a little bit?
Like here?
Yeah, just so in now, just leave it. It's fine.
Yeah.
Okay.
We don't need a walkway.
Hopefully I am. I'm not sitting in work. Can I help?
But no, do I need to go get an 8-foot piece of plywood or something?
I think he's gonna go. I think he's just gonna cut it down.
Okay, that's cool.
It's 4 foot by 8 foot, so it's not a full piece of plywood.
Oh, that's pretty much close enough.
This side.
Yeah. It works with the laser cutter.
Oh yeah. Oh yeah.
So, quick cut.
Oh, no, that's a lot. We need to
It should be like 26.
From where?
From Lowe's, half inch. Half inch? Yeah, half inch. You're like 12. That's a 2x4. Yeah, no.
Here, what are you doing over there?
Where?
You.
Me? Programming the radio.
Okay, are you ready for me to show you the screen?
Give me 1 second.
Need to install Java?
Yes, I need to install Java. This computer was essentially formatted before this. Okay. Yeah, they're currently riveting. Okay, I should be ready when you are.
Okay. You want to introduce yourself?
All right. So I'm Noah again, and I'm going to show you how to easily program a radio. So the first thing you want to do is head over to docs.wpilib.org and go to Getting Started and Programming Your Radio. You need to install Java if you don't have it installed already. And there's a link to install Java here on the site. Here is an example of the radio. And then you need to download the FRC radio configuration tool.
How many? Anna.
You don't need this, do you?
No, not right now. All right, so run the FRC radio configuration tool that you can download from first website. It does need access to make modifications to your computer because it's an installer. Needs to install NCAP, which is a a network scanning tool.
Can I borrow your mic?
I'm currently doing a tutorial.
Okay.
All right. And then we can launch the radio configuration utility. Say the Ethernet network interface. The team number we're using for this event is 1887. You can specify a WPA key if you want, but for this, we don't need to. Then you just press configure. So if you specify a key, then that will give you encrypted connection in the lab. It checks to make sure the radio is where it expects it to be. So occasionally you'll run into issues where having Wi-Fi enabled on your computer can prevent it from connecting, in which case you want to go to Control Panel, Network and Internet, Network and Sharing Center, change adapter settings, and then disable every interface here except for Ethernet. It's also a good idea to do this when you're going out on the field. So now we can try this again. So if you have multiple robots, then you can set a robot name here, and it will appear as team number to the robot name. So if you have multiple robots or multiple radios, and you want to make sure which one's which, that's a good way of checking. All right, I'm gonna restart the radio because it's not showing up. And double check that the cable is plugged in. And we're gonna try configuring it again. These radios do take a very long time to boot up though. So make sure you wait about 30 seconds from restarting a radio until trying to connect to it. No, I didn't. Maybe.
Your screen is set to do. There we go.
Let's check the network adapters.
I did just check the network adapters, but I can check it again. I turned off all my other network adapters.
Can I see your Ethernet card and check if there's a static IP address on it?
You're in CSA mode, Sam?
Ha! Noah and I are both CSAs to help people troubleshoot their robots at competitions. Yes, I'm in CSA mode. That's the automatically resolved IP address right there.
Which should be the correct thing for this case, correct?
Probably.
Because it should be in like link local mode, right?
It may be because you're trying to do it over PoE.
Maybe. We can try it over the other hole.
Do we have a barrel connector for the radio?
No, but we can inject without data.
Oh, can we use the other port then?
Yeah.
Oh, I meant.
Oh, yeah, I mean for PoE, yes, but let's try it this first. And if this doesn't work, then we're going to reboot my computer.
Can you mute our mics for just a second? Oh, it didn't boot yet, probably.
We didn't reboot the radio.
No, but you took power out.
No, we didn't. I'm going to try rebooting my computer. We can switch those two, but I'm also going to try rebooting my computer.
Okay, before you do, can we switch them?
Sure. Maybe that one doesn't work for PoE.
Yeah.
Sorry, go ahead.
You know a little bit more about code than I do. Oh, okay. Yeah. Oh, really? Wait, we can use the controller in the development robot.
So I said you had a question.
Have him answer.
Who has his left?
I do now.
No, can you pause for just a second?
Hello. Now I'm on. A little bit more. There we go. Hi. So to answer your question about our general strategy, low goal and climb is a pretty good representation of that. So one of the first things we realized was that you do want to go underneath the trench, and this is going to save you between 2 and 3 seconds on every cycle if you're going all the way from your loading station to the goal. And the more teams using the trench is tricky because the less teams that use it, the better it is. Because if you're the only team out of the 6 robots on the field who do it, then the 5 robots are all going to be going through the shield generator, which is going to be a lot slower for them. But by going through the trench, you can save those seconds and be faster. So low goals, we opted to do low goals mostly because you need the 49 capacity to get to the extra ranking point to turn the wheel and color match it. If you have a high goal shooter, you're likely going to be sacrificing speed or accuracy, which means you're not going to be scoring as many balls per second as you are in the low goal. You may be scoring more points because your points will be worth double, but by scoring the low goal, you can make up for that through the extra ranking point and by getting the 20 and the 10-point bonuses for spinning the control panel. 1 second. Climbing, so the main reason we want to do climbing is because of the additional ranking point. You have to have 65 points from climbing to get the additional ranking point, and that will come down to either having 2 robots scale and keeping it level, or have all 3 of your robots scale and you don't have to keep it level if you have all 3 scaling. 25 points in this game is a significant margin. That's if you make every shot on the inner shot, you're still looking at 8 shots to make up for the 25 points that you can get in the end game. And that's assuming you can make every shot in the inner, which is unrealistic. I think you're looking at maybe getting 30.
I was going to say, if you download anything,
there's another way. I mean, if they give you penalty points, you can get the ranking point that way for the climb.
Don't neglect the actual moniker of this game, Infinite Recharge, right? The
But
biggest
yes,
potential for
that goes
earning a lot of
going
points.
to the low goal.
Right. Well, the biggest
And
potential for earning a lot of
not
points
necessarily
is
low
if
goal.
you fill up the enemy team's side, the opposing alliance, and you fill them with 15 balls, and then you score more balls. They actually have to enter those back into the playing field right next to your robot. So if they're not ready to take those balls and pick them up, then
that can be, yeah,
extremely powerful.
And that's part of the reason we did decide on the logo. Is generally dumping 5 balls into the logo is going to be faster than lining up your shots into the high tower. So doing this will mean they'll force those balls back out to you quicker, and this will let you cut down on your cycle times by at least 50%. Because all you have to do now is just load, walk over, dump it, load, go over and dump it instead of having to go all the way across the field, at least until they have some member of their team come back and start defending that loading station. It can be very powerful. That was loud. It can be very good to oversupply them with. Yeah, I'm back. It can be very good to overpower them with the amount of balls that they need.
Cut them a little long and cut them down to whatever size we can fit on the robot.
Can you get a proof of concept going?
Yeah, that's what we're working on, 3D printing parts.
All right, yeah. So if anybody's wondering how we're planning to balance the hangar with our climbing assembly, the plan is actually to discuss it with an alliance during competition, because to be able to balance the hangar, you have to coordinate with your entire alliance. Everybody that's climbing on your alliance needs to know where you're going to be on the hook or on the hangar and how you're going to climb and how heavy your robot is. So in order to balance the hangar, you can't really do that as a single team. You have to talk to your teammates, so we're not going to be simulating that in this build. The only way that we could simulate a balance right now is to say, oh, our teammates can't climb. That's what we're assuming, and we just climb up the center. There is no rule saying a robot can push a bar from the heavier side to level it.
I mean, you are correct.
That's a compelling
That
thing
is a
to
good
But
point.
that's very you know, I don't know if
You
I
could
would
totally
want
do that,
a
actually.
robot doing that to my
we're
robot.
gonna check the game rules.
I believe he's correct.
So are they saying one robot's climbed and then the other side like
pushes it?
Or a third robot line pushes the two.
so that the other two are balanced, but then this other one isn't?
Well,
No, so that one of them would be on the ground and push it up.
Well, they can't.
Yeah,
as long as they're not touching the other robots that are climbing, right? You don't want to ruin their climb.
Yes,
Right.
at
But
the
if you're
end of the
only
game.
touching the bar, and that makes the bar balanced.
So there's a couple of places
I bet that's legal.
we want to check for this.
Interesting.
I
I didn't even consider that. Yeah.
I don't think it's something we can do as our design. I mean, that's a
No, but
what
just
do
an
you-
interesting
I feel
idea.
like it's
That is a
something
very
you
interesting
could
idea
do,
to talk about.
but it's not. Yeah.
Nobody tell the people that revised the rule book about that.
It will be asked in the Q&A question.
Or just do it and then have access
Well,
to
I
do it the
think
worst
it's meant
competition.
that way. I think
No,
it's the
no.
first Q&A is going to be.
There actually is a rule that prohibits, 4.4.4 bullet B.
Which one is it? Read that rule.
So this is under the generator switch scoring section. A generator switch is considered level if 5 seconds after the arena timer displays 0, following teleop, both following criteria is met. 1, it is in the level range, and 2, all Alliance robots contacting the generator switch have to be hanging.
Oh, yeah, so no, you can't push
okay.
it. Well, that answers that question. And thank you, Dino K's, for telling us to check 4.4.4 bullet B.
Which we just did.
Which is, that's what I was looking.
I mean,
I think
you would still get points for the
Let's
climb.
I think they're communicating the idea that you use your robot to shift them, your alliance partner on it.
I think they meant the bar.
I think they meant the pushing up on the bar.
Yeah.
In theory, you could do it. You just wouldn't get the level.
But
for
most
it.
teams wouldn't be comfortable with that, I imagine.
Yeah, you could physically push their robots to try and balance it as well.
Just like,
That
just slide
would,
you over a little bit.
Don't
Yeah.
know about that one.
Maybe you could do that.
Thank you for saving our team effort.
Yeah.
Yeah.
Let's see. While I have the mic, I want to say, I don't know their numbers, but thank you to teams RoboDogs and Pyrotech for helping make this RI3D possible. RoboDogs is 435, 3459, Pyrotech. Because I think we borrowed our Robo Rio from Pyrotech and we borrowed a battery charger from 435. So if any of you are watching, thank you so much. We couldn't have done it without you.
Hey, I'm actually Dino K's too.
Yeah, I
It's
know.
Dino Kez. I thought it was funny that you picked me when I was in the other room.
Yeah, I noticed that as well.
You're
'cause
welcome.
I saw you on it earlier. Hey, he's here. This is who you can thank.
Yeah. He did it.
No, that was a really good question.
That was a really good question. I'm glad that we have such good questions in the chat. We were thinking of it as a way to level. Oh, yeah. I wonder if there's anything else that you could do to level the bar without like climbing on it explicitly.
Everyone's still asking about
climb on
the part that says, the part in the rules that says that for the bar to be level, it has to have a robot on it. That's in a blue box.
It has
It's
to
in
be
the table.
hanging.
It's in the scoring thing.
So-
yeah, the bar is not level if there's no bot on.
I'm sure they'll add it to the rules proper though.
In reality,
It'll
there's
be.
a couple of conflicting ideas on here, but the actual definitive answer for it being considered level is that you in the scoring box cannot get points for a level balance if there are no robots hanging.
Yes, you must have at
Right,
least
so that
one
is
to
made
three
explicit.
robots.
Now there's some confusing language around it, but it will probably be clarified in some team updates. But to be clear, you have to have a robot hanging for it to be considered level.
So you don't just get free 15 points. Unfortunately, not.
Yeah. Well, I think that's all I was doing.
In the scoring table, it says with 1 to 3 robots on it.
We got to make a materials run. So, Kaz, do you want to answer questions or something?
There's no questions at the moment.
There's no questions. They can ask
more
questions.
questions at the moment.
I just like put my finger all over the mic. Sorry, chat.
RIP headphones.
I believe that that rule is like, the way it's worded to me seems to indicate that at the end of the match, all the robots that are touching that switch have to be hanging off of it. Or it doesn't
For it
count
to
at
be
all.
level.
For it to be level.
But if you, let's say you have two robots climb and one of them messes up, the other one
Yeah.
can still get points.
You can still get points for climbing.
Yeah.
Well, yeah, but,
the
you could also
question was,
accidentally
leveling the
like.
bar by pushing it.
What if
you
like
could bring it down and then now they're touching,
Yeah.
or you could mess it up.
or it's like
But still.
I'm one robot, I'm climbing in the middle, and I'm like, yes, it'll be level because it's just me, and then an ally like touches it at the last second trying to get up there.
Yeah.
And then your level is lost.
Yeah, it's done 5 seconds after, so you may.
Oh, it's not at 0?
Or maybe I may be wrong. Maybe the level
I don't know
is
either.
determined at 0, but a successful climb is determined 5 seconds after.
Okay.
But maybe the level is determined by when it goes to 0. But with that being said, you don't want your switch to be rocking back and forth.
That's true.
Which means you do have to be careful in that end game not to bump it up.
Mhm.
And sometimes, like, I'm sure you'll see this happen. You'll have a team who's got like 10, bless you. You'll have a team who's got like 10 seconds left, and they're
Mhm.
like, oh, I'm gonna climb.
Yeah.
And then they go up and they knock it around, and then you're going back and forth, and you lose points on the level.
Yeah,
because
I think
they
it's
decide to go in
even looking at the field tour videos, how long that keeps swinging. It could even be like a minute left in the match and you hit it, and it messes you up later.
Okay, I was thinking it did have to be level for 5 seconds after the same thing.
Oh, okay.
So yeah, so you definitely.
Because I
don't
guess
want
you could just get lucky if it was at 0 and it's like swinging back and forth.
But yeah.
One thing I saw someone on Chief talking about is there's a big thread with the like resupply stuff where if you score more than 15, they gotta give them back.
That's a big part of this game,
Somebody mentioned
I believe.
there might have been a follow-up in the thread, I might have missed it, but somebody mentioned what about the human player's physical ability? Can your human player just kind of walk slowly between your power cells and your thing, and they're getting them there. They're just pretty slow.
Yeah, I mean, it's something with back in Stronghold when we had that limit. I do remember matches where after the match we'd be going to like get our robots, and I would see in the whatever it was called, in the thing that held all the balls for Stronghold, I'd see like 8 or 9 balls there, and I'm like, that's over the limit. Why are they not being, and they wouldn't be fouled or anything about it. So I'm assuming that hopefully this year they're going to be more on that.
Yeah, that's a good point.
I believe that they will.
There are 3 human players behind the glass this time.
Yeah, I think with 3 human players.
I was thinking more that there would be 1, and that's wrong.
1 running them back and forth, or 2 running back and forth, and 1 person just shoving them out. But I do think, at least in the spirit of the rules, if you have 15 and you get more, you should be like, okay, I'm gonna roll them out, right? Like, okay, a couple just got scored, I'm rolling 3 out. Okay, there's 3 more, okay, we're good.
Yeah.
Or, so I do think that for 3 human players, it won't be that much of an issue.
Here, let me bring up Chief Delphi and see if there's anything else people are talking about.
I mean, it could, like, I could see people doing, I haven't really looked at the field tour of behind the Alliance wall, so I'm not really sure how much that distance is between that loading station and where the balls are coming out of. I'm not sure what happened, where they go when you score them. So depending upon the location of that, you may have one person who's kind of standing at the goal, waiting for the balls to come in, and who will let everybody know, like, okay, they just scored 3 balls just came in, and then grab them, and then hand them to someone else, and so on. Yeah, I mean, it's not really like that much. I wonder if you are going to have people or human players who try and specialize in like being expert ball rollers.
Oh yeah, like Stronghold. The Stronghold human player meta was awesome.
Because they, I mean, they did mention that in the filter, they're like, oh, you know, no matter what you do, they're not going to go out that much. But you know, I wouldn't be surprised if we see people
all sorts of stuff.
Work on
people figure out how to get that ball to go further than you thought was possible.
Yeah. I mean, and there are benefits of doing that. You can save a couple seconds on your cycle, but you know, sometimes maybe you do want to drop them close. That way they're in that protected zone. And
that's true.
If your opponents don't know the rules and they're like, oh, we just can't enter that zone at all, then that could be big. Like, the thing is, you can enter the zone, just don't get hit while they're in the zone. But if you know your opponent is like, oh, we just can't go in there at all, then just plop them outside and you don't have to worry about it. Cool.
Yeah.
Keep the questions coming. We've got stuff. We have a disc.
There's a big disc. Cool. Oh, okay. All right. I'm here for longer.
2 more minutes.
Sure. Distance between the collection bin behind port and loading station is about 1 Alliance station. Okay. Okay, so it's not right there, but it's pretty close. Yeah, I could. With 3 human players, I guess you're right. It would be pretty. It doesn't sound like we'll get bottlenecked by human players not moving fast enough.
What do you want from me? An STL and a flash drive?
Yes. I have a flash drive.
Alright. So I'll come get that flash drive then.
Yes.
I'm here for a little bit longer while they try to set up the next thing. If you have any more questions. That's a good point. The 15 balls seems like a lot, and it is, but it's also potentially like 1 alliance's worth of cycles that could all come in at once, basically. I wonder if they start enforcing that rule really like there are 2 sides of the coin where maybe they're really lax on the rule, and then it's kind of a problem because the cells aren't coming out fast enough. But if they're super harsh on the rule, you could pile like 15 balls in there at once and maybe cost them something, cost them a foul or whatever the rules is.
So we were thinking about, like, especially in autonomous, I think most teams are going to make an autonomous where it's just autonomous starts, shoot. And if you have all 3 of your robots shooting in at once, that goal is big, don't get me wrong, but I do think there's a good chance that you will have shots deflected.
Yeah.
And that's also part of the reason that going in that low goal may be beneficial. It's because you're just completely out of the way of all your other shooters.
That's true.
So I do think if you happen to have all 3 of your alliance members be in a scoring position at once, you either take turns or you say one of them will get ready to go to that control panel. Because maybe if you're at 10 already and you need that 20, well, why shoot all 15, bring 1 robot back,
oh yeah,
and so on. So you can save a couple seconds doing it that way.
Yeah. Well, I think that's it for us for a little while. We're going to go to the radio programming segment, I'm pretty sure. We'll be back later. At least one of us will.
Goodbye.
See ya.
You want to connect?
Hello everyone, we are going to be showing you how to program your FRC radio. So one of these for use in your lab environment. When you get to a competition, you are going to need to reset them up for the field. But for setting them up in the lab, it's pretty simple, and I can show you how to do that. So the first thing you want to do is you want to go to the docs.wpilib.org website and go to the Programming Your Radio page. And then you need to download the FRC Radio Configuration 20.0.0 tool. Once you have that downloaded, you can run that installer. And then you'll be able to open the radio configuration utility app. You might need to install Java to do this. If you don't have Java already installed, you can follow a link on the website. It'll ask you to select a network interface. So in this case, the Ethernet port on this laptop is what you want to use. You always want to use an Ethernet port for this. It'll prompt you to put in your team number, which in our case is 1887. And if you have a new radio, before you configure it, it's a good idea to load the firmware. So click the Load Firmware button, and it's going to ask you to power cycle the radio. So just unplug power from your radio and plug power back in. It'll say radio found flashing firmware. Now, if you're having trouble connecting to your radio, it could be that it's trying to use some other network device or something. So if you go to Control Panel, and then Network and Internet, Network and Sharing Center, change adapter settings. You want to disable all of the, please don't do that.
Sorry. We're shooting right now.
Okay. You want to disable all of the network devices that you have that aren't the Ethernet device that you are using. This does take a little while. It might prompt you if you want to share devices. It doesn't matter what you say to that. Radio firmware flash complete, but even though the firmware is updated, it's still not set up for your team number yet. So like I said, you need to type in your team number, and then you can put in an optional robot name. It doesn't matter, it'll just display that name for the Wi-Fi network that this broadcasts. And that's useful if you have more than one radio or more than one robot, just so you can identify which is which. You don't need to flash the firmware every time you set up a radio. It's just generally a good idea the first time. And particularly, I was having trouble getting these radios to flash before setting up the firmware, or before flashing the new firmware on there. So then just these settings are all fine. If you want, you can put a password on it, but that's not important generally. Then you just click configure. Now these radios do take a minute to boot up, so if you've just plugged your radio into power, it might not find it on the first try. So sometimes you need to wait about 30 seconds. The light will on top, the power light, which is the leftmost if the Ethernet ports are towards you, will turn off and then turn on, but it's going to be blinking, and then it's going to turn back solid again. And when it's solid again, it's definitely ready for a flash. So this radio has successfully been programmed, and with that, we can turn on Ethernet, or turn Wi-Fi back on this laptop by going back to change adapter settings, Wi-Fi enabled. And then if we look here in our Wi-Fi networks, we can see that there's this 1887 Wi-Fi network now. Connecting to this will allow you to connect to your robot later. All right. Thank you very much. I've been Noah, and this has been our presentation on how to flash an FRC radio.